Why on video chat?
What is the profile? This is what?
What is this? Additional Secretary and MS.
Yeah, we still see that most of the cameras are switched off. Kindly request all the participants to switch on the cameras. We'll not be able to start the program when all the cameras are until all the cameras are switched on.
So all participants whose names are showing up on screen, kindly switch on your videos, please.
So change that. Okay. Good.
People also.
Doing that. That should.
We'll ask them to start. Harish, you also start.
Okay, later. Okay, can do.
And also do one thing.
Because remove IFS. He don't want IFS to be.
Do one more thing. You can turn off non-video participants. Start. And see if you can mute.
All participants, please switch on your camera, please. All participants, please switch on your camera.
Right, non-video participants. Let's go there. As and when people turn their video on, they
Very good morning.
Good morning, sir.
We have with us Sri Bharat Lal, Additional Secretary and Mission Director of National Jal Jeevan Mission here. So he'll be addressing us. I would request Dr. Shubha Muthukumar to kindly take over and introduce the speaker, please.
Thank you, sir. Now I request our head, Mr. Geeta Krishnan, to address the gathering.
Good morning, sir. Good morning, everyone. Welcome to each one of you to the very first webinar in our series of webinars and capacity building training programs in support of the Jal Jeevan Mission. I hope all of you and your family members and friends are safe and healthy in these uncertain times. My name is Geeta Krishnan. I manage the Urban Practitioners Program at the Indian Institute for Human Settlements. We refer to ourselves as IIHS. I'm delighted to note that we have more than 100 participants from more than 10 states across the country attending this very first webinar. I'm confident that this webinar will prove very useful for all of us in implementing the Jal Jeevan Mission across the country. Thank you all of you and welcome once again. As you are aware, the ministry has identified education and communication as key components to the mission. And we at the Indian Institute for Human Settlements will do our best to ensure that the best quality education and training on various aspects relating to the implementation of the mission are addressed. And we are indeed honored to be empaneled as a key resource center by the Ministry of Jal Shakti to support the successful implementation of the Jal Jeevan Mission. We're privileged to have with us today as a guest of honor, Sri Bharat Lal, IFS, Additional Secretary and Mission Director, Jal Jeevan Mission, Ministry of Jal Shakti, Government of India. We look forward to listening to your wise words of wisdom, sir, on the objectives of the Jal Jeevan Mission and what are the outcomes expected in the planning and implementation phases of this very important national mission. To begin proceedings, may I request Sri Aromar Ravi, Director, Indian Institute for Human Settlements, to give us a brief overview of IIHS. Shri Aromar, over to you. You're on mute, sir.
You're on mute.
Thank you, Geeta. Namaskar, Vanakkam. Good morning, everybody. It's really a pleasure to see so many officers from across the country and the mission director on this webinar. I'm Aromar Ravi. I'm the director of IIHS, and I'm really glad to be with you because, I worked in this space for, well, let's say from the 7th plan, sometime, probably before a lot of you came into service. IIHS is India's sort of leading institution that works on a whole range of issues, but fundamentally around the question of human settlements, that is rural, peri-urban, small towns and larger areas. And one of the most critical questions that we've dealt with in this country, I would say over the last 40 years or more, is access to water. It's a very critical question for us. It's been through for the last many years. And I'm really glad that now we have a national mission. I mean, this is probably the 3rd generation mission that I've seen that is taking this and trying to ensure that we have service delivery to some of the most challenged sort of parts of the country. And, it's good to see officers from across the country as far as it's concerned. As an institution, we have extensive work in the water and sanitation sector. We work across 22 states. We're active in capacity building in over a dozen states, especially at the local level. And we have, been helping run large programs for the Government of India. We're primarily an academic research and a capacity building institution. But one of the critical things is that we have the ability to draw on innovation happening across the country. Like I said, we work across 22 states. So we try and bring together, and my colleagues have done this, I think, quite successfully in the run-up to this webinar and our engagement with the mission of trying to hear from state governments what are the particular challenges that we have. Because, the thing about water is highly decentralized. And even though we try and deliver, high quality standard of services across the country, the conditions are quite complex and different. So no one size fits all system can actually work. And the innovation that comes from the states and supported by the Government of India is hopefully going to deliver something quite substantial. But then I think we have to be pretty pragmatic. Today, of course, is on an advanced topic on dealing with monitoring through software. But there are some very basic things that I thought I'd share with you before the mission director comes up and deals with this. And it starts with the full cycle. I think the most significant challenge that we still have, And I can tell you that from the first attempts at trying to universalize access to drinking water in the 1980s is source sustainability. Source sustainability still is a very significant issue, and it's going to become an even more significant issue over time because of the challenges that we are going to see of drought and climate change. I mean, we work extensively on climate change. I'm one of the leading scientists in this business, and I can tell you that as we're seeing in this year's monsoon, because rainfall is going to come in much shorter bursts and more intense, there are going to be a whole range of challenges to manage both surface and groundwater resources. So source sustainability is going to be very challenging, especially because we want regular and high quality water supply at the end of it. And then, of course, there are still many parts of the country where basic geological conditions will not change very much. So we will have a lot of interesting challenges, whether it's iron or it's fluoride in terms of contamination. And they will also be, especially as populations pressures increase and sanitation and water come and become more universal, questions of treatment at source or otherwise. And then as you go towards larger and larger programs, and you'll see this in particularly in states that have well-established networks that are there, states like Maharashtra, states like Punjab, Haryana, which have been having multi-village schemes for a long period of time, the questions of distribution management are not trivial. And distribution management under gravity is one issue. Distribution management in a situation where you have to pump is even more complex, because as we know, energy supply is a big question, not only in terms of cost, but also in terms of actual delivery. I mean, let's say a city in like Bangalore, where we work out of, about 70% of the cost of the delivery of water comes because of pumping costs. So that's another critical question. And then at the end, how do you actually make sure that access is universal? You may actually have supply to a village or a settlement or a small town, but if you don't actually make sure distribution management is equitable, access at the household level becomes a significant challenge. And then, as we well know, when the availability of water shifts at the household level or at the enterprise level, a whole range of things shift. And because we have very, very serious challenges at the gross level and in distribution systems in terms of quality of water, managing efficiency is going to be a new set of challenges as we work itself out. So efficiency management is a tough thing. In the power sector, we've really struggled with this across the country. We're seeing a big transition in the power sector just now from, let's say, fossil fuel to renewables. But the big challenge is actually to make sure that efficiency actually works. And this is going to be a very, very challenging task, because you have wastewater issues, you have a whole range of things that come when you have suddenly, let's say, increased availability of water at the household level, whether it's for animals or for people. Managing that becomes an issue, and that creates its own environmental challenges, which then deals with what happens at the end. Because finally, water is about improving not only access, but improving the quality of health of people. It has environmental challenges at one end, and we run one of the largest programs with the government of Tamil Nadu in the country, which is covering, I would say, almost 10 million people on water and sanitation. And this is really dealing with wastewater and its reuse, because at one end, farmers are challenged. We don't have enough water to be able to maintain ecosystem services, whether it's in forests or other systems that are there. Trying to manage that end becomes very critical. But finally, the biggest question, I think, that I've seen over the years is really making sure that behavior change takes place. Because finally, the issue is not only the question of the right technology, the right distribution system, setting up things and managing it, but it is a behavior change in terms of how we use water, how we actually deal with both waterborne and water-wash diseases. And that's a big challenge. And, I still remember, because I was on the Planning Commission task force in the 10th plan, one of the big things we were trying to do at that time, and this is like almost ancient history, is to make sure that every school in this country has actual availability of quality water. And the reason was not only because children need water, it is because if you actually change the attitudes and practices at the school level, in terms of toilets, like we've done just now with Swachh Bharat in many ways, but also in terms of water access, it changes people's behavior. And that's the most difficult thing to do. You can do wonderful jobs as engineers and public health specialists, etc., across the country, but eventually it depends on citizens' own behavior and how it actually works. So this is a very, very great challenge, and we're very glad that officers and departments from across multiple states are trying to integrate themselves into the process, learn from what's happening in other places, so that we can try and apply these principles quite clearly Fortunately, unfortunately, we're going to be using blended learning, starting with digital learning at the moment using webinars. But we really look forward to having you come and visit us if you have the opportunity. Our campus in Bangalore is already setting very strict standards in terms of water conservation. We've executed now almost 30 million liters of surface storage there at less than 2 rupees a liter. And we're going to be sort of, developing really high levels of recycling of green and black water over the next few years or so. So these things can be done. And we are very glad to learn from you and help you actually move forward in various things. So having said that, I'll hand over to the mission director. I think, this is a matter of great national priority. It's not going to be easy. And there will be all kinds of challenges on the way, including not only setting up the infrastructure, but also on the operations and maintenance side. That's a ongoing challenge that I think we've not dealt with very well in many states. And of course, at some point of time, replacements of the assets that you're taking into account. Just because we put something into the ground or into a system at the moment doesn't mean that it's going to be able to sustain itself. We made those very serious mistakes when we set up the hand pump programs in the 80s. And then by the 90s and the early 2000s, we had to start replacing them and we were not completely ready. So this is the time for innovation. This is a time for a lot of hard work and cross-learning. And we are really proud and happy to be with you on this journey. Thank you very much. And over to Shri Bharatlal, Mission Director of the JJM.
Good morning, everyone. Thank you, Mr. Omar Ravi, Director, Ministry of Human Settlement, Bangalore. Thank you very much. And I thank Course Director and other colleagues. I hope I have been seeing that some participants said that there is a disturbance, actually voice problem. And I think they said that video option is not available. So let me just, I'm sure you must have done the needful, but let me just announce few rules which is followed in every such webinar or training and this thing. Number one, keep your mobile in silent mode. This is the first requirement. Number two, if you are attending this thing, please attend this thing. Don't do any other work. If you want to do any other work, you are free to leave this thing because then you disturb everybody. Third, my request to all to host is that please provide video option to everyone. All those participants, they should be given video option. Without video option, there is no point in conducting this webinar, okay? Because it has to be interactive. It shouldn't look like a broadcast, right? Sure. So please provide immediately and confirm that it has been provided. Video option has been provided. So everybody, whosoever is unable to know this thing, they should be able to do it. They should be able to see. They should be able to My friends, I think I'll take not more than 30-35 minutes, whatever time has been given to me. Let me first compliment all of you. First and foremost, that in last 2 years, you have all at different levels, in different states, different regions, you have done wonderful job. And that's why today Jal Jeevan Mission is considered a fine brand. Jal Jeevan Mission means excellence. Jal Jeevan Mission means something very positive is happening. And I think this has happened just because of you. Okay. So I compliment you, I congratulate you, and I request you, I appeal to you that keep it up, because it's a journey has just started. It has just started. We have to travel long distance, too long a distance. So my first comment would be starting with this program that in last 2 years, I'm 100% sure that each and every one of you must have read operational guidelines for the implementation of Jal Jeevan Mission. If you have not read, kindly today itself, first thing you should be doing that this operational guidelines for the implementation of Jal Jeevan Mission, please read it, because this guideline is not merely some project or some scheme. This guideline provides the way forward how water supply, how drinking water supply, how pipe water supply should be managed in this country. And this guideline basically captures the kind of wisdom, the kind of experiences many people are having. And we have taken help from so many people in different states and different regions, and their input has gone into somebody is typing that audio is not clear. Audio is not clear. Shall I stop? Tell me. Okay, if audio is clear to you, just kindly raise your hand and one go, I'll see that.
It is working. Yes, sir.
It's working.
It's clear. It's working for most of us, sir. So we're just helping the
Okay,
people
so
who
I
are
think
challenged.
1 or 2 people are having some problem. I'll request you kindly check at your end, because I
Yes,
don't
sir.
want that these technical glitches should deny this opportunity to all of you, because I see such sincere people, committed people are here. Their time is very, very precious. You all are basically sitting here to just learn something, and I would like that should be marked. So coming back that in Jal Jeevan Mission, under Jal Jeevan Mission, goal is very clear. Goal is very clear and is very simple. Very clear and very simple. What is the clarity? There are two things. Number one, every household in rural area to be provided with functional household tap connection, FHTC, for assured potable tap water supply on regular basis. First thing is regular basis. Second thing is that adequate quantity, 55 liter per person per day, of prescribed quality. It means BIS standard to be followed. Okay, and of course long-term basis. So friend, this is the first thing. The second is every public institution, is a school, it's an Anganwadi center, it's a PSC, it's a CSC, it's a community center, it's a wellness center. I mean, every institution, our ashram shala means tribal residential schools. Every public institution, there should be provision of clean tap water supply on regular basis in adequate quantity of prescribed quality on long-term basis, but of course with adequate pressure. Okay. And third, within the village, this system has to be managed by Gram Panchayat or its subcommittee, that is Village Water and Sanitation Committee or Pani Samiti, whatever you call it, right, or user committee. So please understand, Jal Jeevan Mission has a very clear-cut 3 specific outcomes. Any of one is missing, no, it's a failure. You have not achieved. Every household is covered, provision is made, means infrastructure is built, but service delivery in what form? At the rate of minimum 55 LPCD, daily supply, regular supply, with adequate pressure, of prescribed quality on long-term basis, because we are building up the system for next 30 to 40 years. Okay, so it is not like for some days or few days or So first thing is that we have to keep. Similarly, all those public institutions in the villages, they also need to be provided with that provision of tap water supply to be made, and again service delivery. And third thing, equally important, any of one, as I said, is missing, it means we have not been able to achieve the goal. So third thing is that we have to build the capacity of local community, local people, user group, Gram Panchayat, its subcommittee, so as they are able to operate, maintain, manage the system. Okay, these are the 3. For third part, it means massive skilling has to be take place. Massive training on water, sanitation, and hygiene has to take place. End of the day, there's understanding and appreciation has to go to next level. Means they should start understanding that this is the way for sustainable water supply. Means if it is drought prone, desert area or water stress area, they should start doing water budgeting. They should start thinking that so much groundwater. I mean, see, people know in India, rural India, every farmer, every family knows that crop can be grown in 1, 2 or whatever seasons. Food grain is produced in this season. And this food grain, they have to use minimum for whole year If drought is there, then second year and third year also. It means they know what is called replenishment. In water also, I think this dialogue, this thought we have to take to them, that water is also is a very finite resource, very limited resource. Every year it gets replenished through monsoon, through rainfall, and in some region through snowfall. Okay. It means we have to go to people and we have to explain to them that every year we get so much of water. And this water, we have to see how much we store, how much we allow to be wasted. And whatever we are able to store, we have to use very judiciously, and we have 2 or 3 uses. Of course, first use is for domestic and drinking water. Second, very, very important and critical use in agriculture. And third is industry. So if, see, all of you are thinking people, highly knowledgeable, in, best in the society. But I think we have to understand the issues in the sector. It is not concrete, it is not pipe, it is not motor, it is not facet. It is all about resource management, service delivery. We have to go to that level. So we have to explain to them, that if you are storing this much water, and storage can be done over the ground or under the ground. Storage has only 2 options. Over the ground, if you have reservoirs, you have dams, you have ponds, please deepen it, desilt it, store it there. Or you recharge the aquifer. So there is no other option. And secondarily, any prudent person, if he or she knows that this kind of fund is available, see, their mind has to start working. That this kind of fund is available at my village level. There is a fund coming from Manrega. There is a fund coming from let's say, SBM. There is a fund coming from Jal Jeevan Mission. There's a district mineral development fund, a CSR fund, and all those things. So we have to convert them into thinking kind of people. That water security, for achieving water security, these funds can be used judiciously on drinking water source strengthening, augmentation management. B, water supply. C, grey water reuse, treatment and reuse. And fourth, regular operation and maintenance. If we are able to build this capacity, if you are able to help in developing this understanding among people, please appreciate that your and my life will become much easier. End of the day, it is they who are going to operate, maintain, manage. It's their village. This is next to impossible for any government that it should post one person in every village and he or she is going to manage. That is the most inefficient management. And more importantly, as per constitutional provision, this year onward, basically started with last year, every panchayat is given sufficient fund for operation, maintenance, and doing all these kind in the form of 15th Finance Commission tight grant for water and sanitation. You and me are not, we don't have contractor mindset. Please understand. We are public servant. We are not contractor. It is the contractor who gets the money, that this much money I'll get and this delivery will do. We are brainy people. We have to work with the people, make them understand. We have to become social engineer. We should be able to start that action. Our effort should be that of course, helping in construction of infrastructure creation, but more importantly, we should be able to force people to start thinking. And there is our success. If we are able to force people that what is clean water, what are the benefits, what are the losses, what are the, suppose if you don't get clean water, imagine if people are, you and me at our home, we are having what we call, let's say, some kind of water treatment plant. Whether it's a UV or simple filter or let's say RO. Imagine, do you think in this country, every family should have this kind of system? Or as a public health engineer, you and me are duty bound to ensure clean tap water supply so that people can drink directly from tap. I think we have to start working. So Jal Jeevan Mission is all about service delivery, all about helping, empowering local people and ensuring service delivery. It means quality, quantity, and regularity, of course, assured basis. The other point I would like to see that kindly see to it. I think most of you know that in your district, what is the arrangement for chlorination? Think about it. I was going through some data and I was looking at that almost 39% samples are failing water quality test. As a public health engineer, I think I should feel ashamed in my area, under my nose, why samples are failing, why they are failing for quality test. I think what I'm trying to hint at to you, that we all join this service after doing civil engineering or maybe mechanical engineering, join public health engineering department, and you got this badge of honor that you are public health engineer. So public health engineer means, yes, you are doing contract management, you are doing tendering, you are doing arbitration, you are doing project management, everything fine. But as a public health engineer, you are responsible for ensuring clean tap water supply. So for that job to do, it means you have to have more knowledge, more understanding, more insight into public health engineering. Public health engineering means solution through engineering. Public health objective to be achieved through engineering, because you are technological people. And then you will be converting yourself into utility managers, where basically not only supply, but grievance redressal is very crucial. And when you become utility manager and you are talking to people, it means you are a facilitator, you are a social engineer. So please understand, like we bureaucrats have multi-dimensional personality. I think time has come when you people have to think about that you are a public health engineer, you are a contract manager, you are a utility manager, you are a facilitator, you are a social engineer. Talking to people, meeting to them, sitting with them is very, very critical, very, very crucial. Okay. Let me give you, because this topic is more about software and technology. Let me give you some perspective. Today, technology has empowered me so much that if I am having some complaint, I can put it on social media and within few seconds, my complaint, forget about reaching to you. It can be broadcast to world over. World over. It means as a public servant, we have to develop a system. And system has to have 2-3 things. Number one, we should acknowledge that today technology enables people to magnify, to amplify their problems, their challenges to whole world, not to only you. It means we have to have a develop a system where people should have faith in us, that they should, if they have some grievance, they should complain to us. Instead of broadcasting. And B, it means we have to have a system where we should be capturing it and then remedial action is taken. If we are not ensuring that their people's grievance are captured by us, and we are not ensuring that on that grievance, we immediately react and take action, then there is a problem. Then there is a problem. Please understand, I think your and my life will not be, will be comfortable, because we are into business of service delivery. And I need not to mention here again, repeat it, that there can't be more critical service delivery than the water supply. For a moment, I can understand if I have to say, yes, it is more important than your hospital. So it means we have to develop a system. The next dimension, which basically this technology adds, it means everything today. You can't remain a backward. That in today, whether it's a Google or it's a Amazon or it's a Flipkart or everybody, totally they are digital. And 90% you people are engineer in your department. And this department, public health department, water and sanitation department, they cannot remain a backward kind of thing. It means digital governance has to come. When I talk about digital governance, it means whether it's a project planning, whether it's a designing of the scheme, it's a let's say data capturing, project monitoring, or let's say water quality testing. There is water quality management information system. It means sample collection. Like you must have heard and must have experienced, few of us who were not so fortunate, I think we have experienced that we got infected by COVID, this virus, coronavirus, and we have to get our sample tested. And just imagine that if citizen, they don't have this testing facility, what will happen to you? And second thing is that once you give the sample, imagine the system has been built that their phone number is available and location of the laboratory is available. In the same government, your sister department, health department, is ensuring that your sample is collected, it is tested, and report is shared with you. Report is also shared with the district administration or municipal authorities for remedial action. I think if we don't learn, we don't improve, we don't profess, then it's very sad actually. I think people like you and me, we have to learn that in this country, if in health sector, such a beautiful system has been developed, where basically our labs are, their location is provided on this app. People can get their sample tested. They will get report as quickly as possible. Initially, it was taking time, but today I think average you can get your report within 24 hours, maybe in some areas 48 hours. And immediately, state government designated people, they basically start acting on it. When there is a delay in sample collection, suppose your father, your mother, your husband, your wife, your children, somebody get infected and his or her sample, there is a delay. What happens to you? If getting the report, there is a delay, how restless you are. If there is a delay in remedial action, that patient is not taken to hospital, not getting bed, not getting this thing, what happens to you? Let's treat the others the way we would like to be treated. Let's not be hypocritical person. A country can be made that if we all, each one of us, performs his or her duty diligently, sincerely, and with the same commitment. The kind of services you expect from other. If we expect that in this phone, this call drop should not take place, please ensure that your tap water supply system, it should not be deficient. If you expect that your blood test report is given, if you said that your saliva or your for COVID test report should be available, please ensure that your laboratory is working and is open to public and report is given immediately, instantaneously. If you expect that your grievance for passport or any kind of driving license or anything, this country should be able to give you instantaneously, please ensure, first you should ensure that others should get the same service. If you expect that everything should be digitized and from your home, you should be able to book that railway ticket or airline ticket, please ensure that you are also doing the same for others. This is the way nation is built. This is the way we build society. This is the way we contribute and make our life meaningful. We are not burden on the society, because society, public is paying my salary. My children are getting education because of this very public. My wife is able to have a home, what she called home, because of this public, and I'm very grateful to this public. So I think we have to bring that sense of service. We should make our life meaningful. That whatever job has been assigned, I'm trying to do it to best. That is called pursuit of excellence. That each one of us has to pursue this excellence. There can't be any other way out. My dear friends, as an engineering person, daily you have to improve. This training, this capacity building, is just simply one small step in that direction, that this kind of facility, this kind of avenue is available so that you can improve. Please forget that whatever you have learned 5 year, 10 year, 20 year, 30 year in your engineering college, that is sufficient, or on the job, that is sufficient. No, there can't be any alternative for better education, better training, better, no. I think there just can't be. Please improve yourself. I am repeatedly saying in terms of you should become a thinking person. You should become a public health engineer. You should become a utility manager. If you should be, everything should be digital governance. The era of file, paper, formal letter, this has ended. Please. I think similarly, as I mentioned in the guideline, we have made provision that your all tendering, it can be item rate. EPC mode, item rate. Why? Every executive engineer, if suppose has to take work for 200, 300, 500 villages, and everybody starts tendering 500 tender issues, you are doing great disservice to public, that you are not getting the benefit of economy of scale. Economy of scale. And B, your precious time should not be wasted in tendering and tendering and tendering. So what we have done, that for likewise area, suppose in 500, 1,000, 5,000, 10,000 villages, work has to be taken up. It means what you can do very easily, that you know the for single village scheme, what are the items? What are the items? Basically, all items should be, it could be 200 items, 300 items, that listing should be done. And two-stage tendering, that 500 work, you want A, B, C, D category contractor, please mention in that. And for the whole district, for number of district, for whole state, this tendering that can be done, that A, on the basis of turnover or experience in A category, B category, C category, tender and D category, number of such contracting agencies, civil agencies can be impaneled. And then next stage, their financial bid could be open. And the financial bid, you find out the L1 for each item, and then give an offer to everybody. Whosoever accept all those offers, it means at this rate, so many agencies, A category, B category, C category, D category, have been impaneled. As a chief engineer, what you have to do? In your district, based on SOR, prepare the cost of the scheme. You have already tender rate. In next column, you put tender rate. You will find out that as per SOR, what is the cost of this scheme, and as per tender, this thing, what is the tender cost. And straight away, your system should be built that for A category, suppose 30% contract will be given to A category, next 25% to B category, 25 to C category, 20% to D category. So you and give contiguous area. It should be computer easy. Nobody can raise any question. And the software should be there, and work is allotted. Work is allotted. Imagine you will be saved from repeating daily so many tenders. Why? You will get a benefit of scale. With this competition, you will your tender price will go down at least 15 to 20%. If you do project monitoring by using some kind of even Excel sheet, if not software, Excel sheet, imagine the timeliness, the cost overrun. What we have learned all, no, per CPM, that whether my project is on time or not, whether my project implementation is on time or not, which is where I'm missing. So use technology, and justify that you are a qualified engineer first. You are a qualified engineer. Please make sure that you become a public health engineer. Please develop that managerial skill and management skill, that you become a utility manager. Please develop those speaking skill, presentation skill, talking to people, so that you should become a good communicator, very good communicator. Basically, social engineer, reaching out to people. Suppose in every village you are able to develop and educate 7, 8 to 10, 15% Gram Panchayat member, 10 to 15 member village water and sanitation committee member, 5% water quality testing, 5% especially women, 5, 6, 7 plumbers, electrician, mason, and pump operator and this thing. In every village, if you have been able to create a cadre of manpower, of human resource of 30 to 40 people who understand water, sanitation, and hygiene. Think about the change in country. In 6 lakh villages, into 30 to 40%, You have educated 1 crore people who have the sensibility, understanding of water, sanitation, hygiene. Imagine the life will be changed. If those people have developed a sensibility, they can decide that they will reduce water consumption in agriculture by just 5% or 10%. They can decide that they will not draw water from the same groundwater aquifer from where the drinking water supply system is there. And imagine the lifespan of your scheme, which you have by your sweat and blood, you have helped people to construct. Imagine its life is elongated. It lasts full life. There can't be a better satisfaction. If the scheme you have constructed in the village, it basically runs for next 30, 40 years. Its sustainability has to be ensured. It means we have to work with people, we have to educate them, we have to sensitize them that source, this drinking water source should not be competing with any other sector. Drinking water source must be protected, must be, like in forestry, you must have heard, there is a sacred groups. You must have heard in every forest area, tribals have their sacred group. They protect that sacred group. They don't allow that sacred group to be damaged or destroyed. Similarly, I think as a public health engineer, we have to ensure that drinking water sources are protected. They are not depleted. And this education, if you bring, this societal pressure will bring on the village. The village people themselves will come say to people that let's not draw water from this aquifer, which is used for drinking water. I think we have to work in that system. Village people themselves start thinking that this Manrega fund or 15th Finance Commission grant we are going to use in recharging aquifer. They are going to do for same thing for grey water management for 15th Finance Commission and SPM fund. They can upkeep, they can maintain this scheme from time to time, whatever little bit repair, maintenance and upgradation is required for water supply scheme. It is taxpayers' money, your money and my money which we are spending. And we have to get best value of that money. It means it requires regular, proper operation, maintenance and management, repair. Who will ensure that? Please understand this Jal Jeevan Mission is a one-time investment. One-time investment. It's not that is going to continue. It will come to an end in 2024. One-time investment for changing this country, for ensuring clean water service, pipe water service delivery. So please work for that. Use technology. Use and I think I can keep on talking a lot, but I think here I'll stop. But end of the day, your role is multifaceted. Your role is changing. Please understand, let's get out of contractors' mindset that we have got so much money, so I have done this much construction. Get out of it. Please get out of it. You are here to ensure clean tap water service delivery on regular basis. Get into that to ensure that service delivery, whatever is required, should be done. It's not very difficult. Again, I would say that in every house, in every home, we are used to those kind of traditional management system, that existing resources, existing infrastructure are dovetailed, they are used. Never ignore, never, whatever existing charges, source or system, they should be used. Please understand it has to be operated, maintained by the village people. It means operation and maintenance cost should be minimum. Should be minimum. And it should be easy to operate and maintain. And here are the technological options you have to use. In some areas and in wherever possible, please develop gravity-based water supply system. Don't get fascinated with multi-village water supply system. It requires huge pumping, it requires huge manpower, and your and my salary or pension we will not get if we start irresponsibly constructing multi-village system. If there is an option, the most preferred option is single village, gravity-based system, if possible, and in isolated small hamlets, wherever feasible possible, we should use solar energy. Because then vulnerability of local people is minimized. End of the day, I think people have to contribute for whatever service. Water is free. But if water is to be pumped and electricity charges to be given, it means the people who are taking these benefits, they have to pay the electricity. They have to pay for something, service charges. So please prepare to your village people, to communities, that they should develop that system. And that's why I say that instead of you doing everything in the village, please ensure the village panchayat, the gram panchayat, the VWSC, the Pani Samiti, it should be doing, because for them it is much easier that from every household they can collect water service delivery charges, they can operate chlorination, they can maintain. From last point, I would like to say that for you people, Jal Jeevan Mission is your program. So for you, we have developed a dashboard. Please type on your laptop, on your phone, JJM dashboard, JJM dashboard. You will get a beautiful dashboard. Please go deep into it. It gives national picture, it gives state picture, it gives district picture, it gives your village, each village picture. Please don't ignore. Please ensure that all data are entered, because this is for your use. All connections which are given, it should be entered with, because they are customers actually. End of the day, they are customers. If geotagging, whatever assets are created, geotagging should be done. If you have not done, it means, let me tell you very frankly, that as a boss of that area, as active engineer or civil engineer, your bona fide gets into doubt, because it means you don't believe in transparency. If geotagging of the asset has not been done, it means you have something to hide. If whomsoever connection has been given, their name has not been entered, it means there is some hanky-panky is going on. If you have not updated the data of village water and sanitation committee members related to, let's say, 5% women who are to be testing water, it means there is some problem. You are not doing your job properly. So kindly ensure that all these pump operator phone number details are not given, it means you are hiding something. If skilling has been done and those 5, 6, 7 people, their details have not been entered, it means we are hiding something. So kindly be very clear that for in your jurisdiction, for each and every village, data should be entered. And in that system, there is already, when you look at the village wise, you will find that it also asks that in last 3 months, whether water sample has been tested in the village or not. And if you find that in last 3 months it has not been tested, please be ready that at some stage there are going to be some serious problem to you, because you have ignored public health. Please don't forget, in today's world, even doctors are being prosecuted for dereliction of duty. Doctors are prosecuted for dereliction of duty. People claim for damage. I think you must have seen that these things are happening. So I think we have to be ready that as a public health engineer, what all have to do, I must do diligently and use technology. My dear sir, somebody is having his or her mic on. Please switch off your mic. Please switch off your mic. Mute your mic. Because you are disturbing everybody. So my friends, it's an era of technology-driven, IT-driven society. And we have to raise our level. We have to match the society, the modern youth, the modern, youngsters. I think we have to raise our level. It can't be possible that we ask them that they downgrade their level. We have to raise our level. So kindly ensure that. I'm sure we are doing a lot for training and capacity building. I think, let me tell you that we have identified 100+ training institution, best training institution in the country. And for all levels, whether it's engineer-in-chief or chief engineer, super engineer, or active engineer, and DE and down below, for everybody, we are customizing training program. We are also developing an Apex Center, an institute, which you should be proud of. This institute will be located in Calcutta. And this institute is basically meant for public health engineer. Is a kind of, it should become your alma mater. So this, we are going to have this National Institute for Water and Sanitation Management. We are going to have in Kolkata. We are developing 2 centers of excellence, one in IIT Chennai, Madras, and second in IIT Gandhinagar. basically is a kind of public health engineering department, full health department we are developing there. Basically, this is for you, for your training, for your master program, for your certificate program, whatever you want to do, basically because it's a knowledge-based society, so improve your knowledge, your understanding. And thirdly, we are setting up five institutions, professor chair. IIT Guwahati, IIT Kanpur, IIT Jodhpur. IIT Guwahati on water treatment, water technologies. IIT Kanpur about data science and informatics, and IIT Jodhpur about sustainability of sources, right? And two other institutions, IIM Bangalore. You will have the opportunity if your work, because there will be selection process. If your work is good, you will be sent to IIM Bangalore for next level of training and next, So IIM Bangalore is basically for utility development and water economics and service, this thing. And Tata Institute of Social Sciences, TIS Mumbai, basically local self-government and governance, right? So kindly, and the Center of Excellence which we are setting up in IIT Madras and IIT Gandhinagar. IIT Madras is mostly about technology, sensor and beds and all those public health engineering technology. And IIT Gandhinagar is more about sustainability and systems. So we are trying to do, and we are also working with 3 other countries, especially Israel and other, Singapore and Hungary, to develop customized course for you people. So avail it. My only request is that please read Jal Jeevan Mission Operation Guidelines. And there is another book, is called Handbook Margdarshika for Gram Panchayat VWSC on our website. DDWS website is available. Please read it very carefully. After reading, I'm pretty sure you'll feel better, because you will have this confidence that you are having now better knowledge, better understanding what ought need to be done. With this, this thing, 2nd October is coming. It's a 1 year of 100 days campaign for providing water, tap water in school and Anganwadi. For our children, we do everything and provide them water. You are being paid and your house is running because of that salary. Please ensure that before 2nd October, when schools are opening, in every school, in every Anganwadi center, there is a tap water for drinking and cooking of meals. There is a hand washing facility. Because if you and me needs hand washing to save ourselves from COVID, our children need more. Let's not feel guilty tomorrow that we as a society failed our children, our future generation, when they need it at most. As a public health engineer, don't fail yourself. Don't fail yourself. It is your duty, your dharma, that every child should have clean drinking water, pipe water supply in a school, hand washing facility like your child has at home, and in toilet and urinal. I think let's build that kind of modern India and be part of making up that kind of India. Friends, I wish you all the very best. Indeed, it is a privilege to talk to you people, to have, this thing. I don't know if you have any kind of question or no, we don't have that, this thing. Perfectly fine. If your questions are there, I'll always love to interact with you. Please use this opportunity, learn as much as, and make a habit that daily in the morning you are looking at this JGM dashboard. Daily have a look at DDWS, the Department of Drinking Water and Sanitation website, DDWS website. You will get a lot of information. Please start using your phone and laptop by accessing this information, the power of the technology. Please understand. Today, I think we are so fortunate that when we were young, kindly recall your younger days. You have to go to university, you have to go to library, you have to go to museum to learn all these things. Today, we are so fortunate that knowledge is coming to us. Knowledge is coming to us on this. Use this thing. When we were a student, we didn't have that kind of access. Today, every knowledge is here actually on your laptop, on your, this thing, you have to come. So we have to develop this practice and, that whatever program I'm doing, let's learn, let's read. There are 3 basically documents: operational guidelines, Margdarshika, and third is 100 days campaign. Read again and again, internalize its essence. These guidelines and handbook is basically to make you a very proud public health engineer, a knowledgeable person.
Kindly use that. So friends, thank you very much. 2nd October is coming. It is a great day for all of us. We are going to have nationwide Gram Sabha, BWSC meeting. Please start working on that, this thing in your area. Village Water Sanitation Committee and Pani Samiti meeting takes place on that day. Use technology. We will try to use the technology that they are connected. By using technology, it is possible. I think it's your skill, your knowledge, your application. And we'll also try that some big VVIP also joins and encourage people, and you are doing great work. So thank you very much, and wishing you very best. Have a very fruitful this further next session, and enjoy, learn. That is my message. Thank you all. Thank you very much.
Thank you, sir.
Thank you, sir. Thank you, Srilal. That was really inspiring. It set the tone not just for today's webinar and not just for the training, but also for the planning and implementation of the mission. So thank you very much for taking your time to address all of us. Appropriately, you talked about how technology is kind of becoming very critical and how we're using it in all streams of our lives. And today's session is actually titled Software Applications in Water Supply Systems. So we know that technology in the form of software, hardware is kind of taking over all aspects of our life, and it's important to harness it efficiently in various aspects of our work. And that's really what we will be looking at today in terms of how we can use software to manage and monitor our water supply systems. So I will now hand over the session to Ms. Shubha Muthukumar, who is the program lead for the Jal Jeevan mission at the IIHS, so that we can begin with the content of today's topic. Thank you very much, sir. Thank you for your presence today morning.
Thank you, Geeta, and thank you all for your words to begin with this webinar. And thank you, Bharatlal ji, for your words to completely understand the technological intervention. You have covered almost every operation guidelines to know that. The main thing for this software which we want to promote and we want to understand, it's like the software is available like 15 years, but we understand as from the public engineering side that mostly consultant takeovers the software time. The people who have been the ownership try to not understand that much. So the indigenous software is one of an important aspect, like Make in India scheme is also parallelly running up. So we want to understand in the context of rural water supply. The very important aspect is to be considered. Most of the water utility expect the software to be indigenous, easy to handle for their day-to-day planning and operation. For the purpose of design and sizing of new water infrastructure and retrofitting, optimization, and even the water quality. So we thought this is one of an important aspect because, as you said, daily we try to go through the JJM dashboard to upgrade ourselves. So we thought that the top states of 10 states almost covered 85% of water supply. So we thought that the existing distribution network, what they are planning, if they retrofit, what they have to do, in the decision support making, the water supply should be planned. So that's why we thought that the software application is one of an important. And we are introducing 2 indigenous software and 2 other software, which is already promoted like WaterGems and EPANET tools, which is also easy to handle. So today's session will be focused how this type of salient features of these type of software can be used in the distribution network and to the rural context. Because we are crossing the borderline between the urban and the rural. So I ensure that how this rural has to focus, what is the performance evaluation to be done in this, what is the checklist should be ready with them to understand the software. So that is the session goes on. So this is the sessions which we are planning it. The first session, which will be given by Dr. MBVS Giridhar. He's head and professor Center for Water Resource from JNTU Hyderabad. In fact, I was working with him for almost 15 years in this water sector, and he is called of source sustainability man. Actually, he have done marvelous and a lot of source sustainability activity exclusively on the rainwater harvesting of complete Telangana and Andhra Pradesh, actually. So he have been a lot of done in the rural water supply, these type of EPANET tools as a project. So we thought that we bring him to to understand how these systems works really, what are the merits, demerits, how to overcome this. So now I request Dr. MBVS Giridhar to join the webinar and present his screen and take half an hour for a session. And finally, after all speakers, we have a Q&A session. Mostly it will be answered in the chat box. And if you have any questions, please participants, raise your hands. We will give you time. So can I request Giridhar sir to join?
Thank you, madam. Namaste to all the participants. Madam, can you give me permission to share my PPT?
Yeah,
Yes,
sir,
it is
we
given,
have
sir.
given. We have given.
Yes, thank you. So now time is 11:50. So I'll be taking up to, as Madam mentioned, it is a 12:20 because other speakers also there. I'll try to restrict myself by around 12:20. So before starting the presentation, if you recall, Sri Bharatlal sir mentioned the use of the technology, geotagging, maintenance, electricity reduction in the pumps uses, and geotagging, and it is a gravity-based management, and use the web technology and geospatial technology. So in fact, my presentation is focused on those points. So in it was mentioned, I will be discussing with APONET tools. Later on, I modified my presentation APONET with GIS5. And in the subsequent slides, I'll try to crush and try to move fast straight so that we can complete the entire presentation within half an hour. And I understand from the organizers, the presentation will be shared to you. So if you have any doubt, you can open and you can see the slides. So at the present time, just see what we are going to discuss, how it can be done, how it can be geotagged, how the maintenance is less with the GIS5 software, and how we can reduce the consumption of the electricity, as Sri Bharatlal sir mentioned. And this is the day of the hour. All of us need to use the technology, maybe IoT-based, internet-based, things-based, or web technology, and geospatial technology. So ours is a water distribution system. We started initially designing the pipeline by putting on a tracing paper and using the calculator, using the mathematical calculator, then using the program Excel sheet. Next development using the Excel sheet, we used to calculate all the pipe diameter, what is the discharge required, what is the pressures, and what is the losses. Then we move to the softwares like APONET and JUMP. And APONET is a very good software. All of us knows it is a water distribution network system. And we can find out what is the pressures and what is the elevations and what is the discharge, what is the peak demand. All we can calculate by knowing the details, by collecting the details from the field. That is the APONET. But now you can augment the technology, augment the design using the technology that is a geospatial technology, and you can start using the GIS5. So difficulties in the GIS5, you can overload, or you can take an icon of the APONET in the GIS and you can start work. But the advantage of the GIS is the geotag. As sir was mentioned, everything need to be geotag. If you use the GIS5, it is geotag. And just connect to the Jal Jeevan Mission or that JJM dashboard directly, that can be connected to the Government of India website, Jal Shakti Mission. That is advantage with the GIS5. Another advantage, the beautiful advantage, and it is easy for all our engineers is we'll get all the elevations and locations, the spatial features and coordinates, then lengths, all we can get it using the Google Earth, which can be downloaded in the GIS5. In fact, if you want to use the APONET, we need to go, if you want to use the APONET standalone, APONET alone, then what we need to go to the field and measure the length from one pipe to the other pipe, length from one corner to the other corner, then come back and put it in the software and enter the details. Take the elevations using the GPS, come back and put into the software and design it. But with the GIS5, you'll get the lengths as well as elevations, reservoir diameters, locations, number of alternative pipelines we can create in the GIS5 by sitting in office, and it is a geotag. And we can take the number of alternative routes and we can reduce the velocity and we can put the various walls in the GIS pipes loaded with the APONET very easily. So that's how we can use the technology. With this, I'll start. And thanks for the opportunity given for me from the IIH. I thank to the Sri Geeta Krishnan, thank to Sri Armor, and today's chief guest, Bharatlal sir, has mentioned, explained the need of the water supply system need to be designed with the present technology that's focused very, very excellently. I'm very happy and appreciate Sri Bharatlal sir for guiding all of us. So with this, we'll move forward. So this is the some places they're just line, pump, maybe reservoir may be upside, maybe a downside, the area's elevations, and where to put the wall, where to put the air release wall, where you put the pressure release wall, where you put the vacuum wall, where you put the combination wall. These all we used to do on the paper, and number of iterations manually. This we can overcome with GIS5. Very easy where to put the walls and all in the GIS5. So this is the Google image. So if you want to design a pipeline, so what we'll do in the field without using the Google image, without the GIS5, if it is upon it, we need to go to the field and measure the length from one to another place, from here to here, from here to here, from here to here, and how to connect it using the pipe network, Hardy-Cross method, and calculate all the demands and changes. But here now, once the image is ready, just see now, this is the lines created. Now we know the length without going to the field. I know the elevation here, I know the elevation here, I know the elevation here. Of course, there is a little approximation, maybe 1 or 0.5 meter to 1 meter relatively error, but if the error is uniform on all the nodes. So if you want to get all this network connection for this small area, if you are having the GIS5, within a day, within a half day, I can prepare. If I know the population, I can calculate the demand at each and every node, and I can connect it. Now I have the facility, whether I need to connect this place from this pipeline or this pipeline. It's all sitting in the plan, and connect it, I can run the simulation. If the velocity is crossing our limit, if the pressure is crossing as per the pressure standard selected by the pipeline from the warehouse, then you can modify it. If the demand is more here, you can replace only this pipeline. Such a technology is available. All these are geocoded. All these are geocoded. And we can find out what is the elevation here and what is the elevation here. If the elevation is low, and maybe we can suggest for going for another reservoir here and arrange by gravity. And arrange the distribution, design the distribution by gravity. This is the advantage of the GIS5. So we are all experienced with the GA upon it, which it works. The same can be loaded into the GIS5. The advantage and the usefulness is it is a geocoded. Geospatial technology we are using, and we can have a number of options to change alternatives so that we can reduce the electricity on the pumping cost. We can change the diameter and run the simulation, see what is the loss, and change the diameters and change the air release walls, pressure walls, and run the simulation. Once this basic network is ready on the GIS5, we can run and we can do number of simulations, and we can go for a best design based on the less maintenance required, less electricity used, because electricity consumed means we are releasing 1 kilowatt hour power, we are releasing 900 grams of CO2 into the atmosphere. So we need to be keep in mind. So this is upon it, this is some of the basic definitions because of the time, and all of us knows it calculates movement of the drinking water in the entire system. And it is a water distribution piping system developed by Environmental Protection Agency, and we can simulate. What simulation we can do with respect to the population increase? We can simulate as over the 40 years, 50 years, increase the population and simulate, and what is the discharge required, whether our pipeline can carry it. With the pipeline, with the same diameter, if you release more quantity of the water, velocity increases, the velocity increases, pressure losses increases, the pressure loss increases, pump capacity requirement is more, it consumes a lot of electricity. So we can simulate it, and maybe for another 20, 30 years, we can calculate. We can forecast the population, and accordingly we can design, and we can simulate for various on the time series for today, 10 years, 20 years, and 30 years. And we can say that our pipeline system can work with the population of X so and so up to next 40 years. We can see what are the pipes, what is the nodes, what is the pumps, whether it is a variable pumps, it is a fixed RPM pumps, and what type of walls it is, all we can place it, and we can find out, including quality also, but quality we are not discussing here, and we are only discussing the distribution. We can find out flow of water, we can find out the pressure at each and every net, each and every node, height of the water in each tank, what are the chemical concentration moving over a period of time, because we are adding the chlorine, and we can also find out the source, which is source of water we are sending into that. It has a capability color-coded network maps. You can data tables, end of the simulation, we can prepare the tables and submit to the reports. How much energy it is used and what type of reaction is happening, what is the calibration we are doing, and how we are simulating on a time series. And we can prepare the time series graphs. We can find out the profile plots and contour graphs. So this is the capabilities of the hydraulic modeling of capability of the EPONET. So it uses there is no limit on the size of the network that can be analyzed. We can calculate the head loss using 3 popularly used formulas. We can select any one, and we can also calculate minor losses for the bends and fittings. And we can also use various pumps like a variable pump speed, variable speed or constant speed, and you can prepare the performance characteristic curve by using various pipes. This all simulation can be applied in the EPONET as well as in the GIS pipe. Computes the pumping energy and cost. So this is what Bharatlal Saurabh was mentioning. As engineers, we need to reduce the energy, uses of energy, and reduce the cost. That's where we can involve more and we can do more with the maintenance free. Models, various types of valves we can put, where to put the check valve, pressure release valve, and simulate the flow. And we can understand whether really what the valves location of identifying various types of valves is very, very important in the water distribution system. To release the air, to release the pressure, non-return valves, there are various types, but location of locating a particular place for what type of valves, it is very, very important. So these are the, can have a multiple demand categories at each nodes. Multiple demand means morning demand may be more, evening demand may be more. We can also find out pressure dependent flow, simple tank level or timer control, we can do it. We can also prepare various types of curves, pump curve, efficiency curve, volume curve, head loss curve. These are compulsory we need to do in water distribution system. Many a times we calculate the diameter and velocity and pressure loss, but we may ignore the pump curve and efficiency curve, volume curve, and head loss curve. But these are the important, we need to do it. That's where we can reduce the maintenance and energy cost. So these are the input parameter and output parameter. All of us knows what is input parameters need to be given and what are the output parameters need to be given. And these are the various types of valves need to be selected where to keep it. Maybe pressure reducing valve, pressure sustaining valve, pressure breaker valve, control valve, and all these types of valves. We can also do rule-based control. That is advantage in the EPONET. Combination of various conditions by knowing the initial hydraulic state of the system. Once it is completed, then we can do rule-based controls. So data inputs required, elevation of the nodes. So this I was mentioning, elevation we need to get from the ground if we are using the EPONET. And if we are using the GIS pipe, and if you overload the Google Earth on that, and elevation will be automatically can be taken from the Google Earth. No need to go to the field. Demand can be calculated from the field, as well as we can run the pipeline and on the GIS pipe, and we can calculate what is the demand coming for a particular from one node to another node. Length of the pipe in the GIS pipe, directly you can draw the line and you can find out the length of the pipe. Once you know the length, you can find out the diameter. Roughness is standard parameters, you can do it. You can calculate the pump head, take the elevations, minimum, maximum elevation. This also Google Earth helps us. So these are the special reports. So we can prepare various reports, status report, energy report, calibration report, reaction report, and the full reports saying that how much energy we are consuming and what are the losses. So we can also do the water EPONET distribution for sampling program, hydraulic model, chlorine residual. We are not discussing about the quality here. We are concentrating on the quantity. These are the 6-step procedure in the EPONET tool. Draw a network representation. Take a background help of a GIS pipe. It will be geocoded. It will be geotag. Edit the properties, maybe pipeline. So once after drawing the representation, if you're not happy with that, you can edit it. Increase the diameter, decrease the diameter, change the walls, and change the length, change the node connections. Then describe how the system is to be operated. Set the analysis options, how we want to do it. Run the hydraulic water quality analysis, see the results. Then once we satisfy, once we meet the requirement of Ministry of Jal Shakti guidelines, then we can do, we can say it is our village level water network is perfectly working. So I'm going into the GIS pipe now. So because most of us may not be aware, I think some of the engineers may be already working, but I am trying to explain from the beginning in the GIS pipe. And this PPT will be shared to all of you. And it is a very helpful step by step we are given, and you can download and you can work with the GIS pipe. So this is how to install the GIS pipe software. So download GIS setup.exe. Nowadays we are all familiar with this system, how to download the softwares. So this is the GIS pipe. Go to the download. Then GIS pipe comes. Just say it is a download executive file, right? Then double click on that. So we can run it. Open the double click on that, and just to say cancel for this, because if you register, they may ask for money. And because we are student version we are using, if you want to purchase, give your company, your office name and email, so that they will ask registration and they will ask payment, and you can purchase the one directly. For working purpose, you can download as a demo model. And this is the workspace to work in the GIS pipe. This is the GIS pipe evaluation. It has a water distribution network model and stormwater management model also. Both. Nowadays, it is a stormwater management model under the CPHU released a beautiful manual on the stormwater management model, but I'm not touching on that. It is a water distribution network model. Very clearly, it is explained. So it has a various layers. Google Map you can call here. Bing Map you can call here. Street Map you can call here. All layers you can open it. This is the Google Map. Many a times we are working for the Google Map. We want to go from one place to other place. We are depending on the Google Map. So this is the Bing Map, and open the street maps. So to draw water line network and all. So we have various options. You can go for a new, or if you have you can import it, we can export it. These are the options available with this. This is the import and this is the export. You can also remove from here. So this is what it is. You can also see the table. So once this network is ready, this network we have not gone to the field by sitting in the office, by adding the street layers into the layer in the Google Map, then we have drawn it. Maybe for verification, we need to go to the field once everything is calculated and all, to check what is the pressure we have calculated and what is the pressure it is coming. We can go and verify in the field. The advantage with this is the document is available with us and it is a geocoded. Anytime if I would like to know what is the pipe diameter I have laid here, we can see by seeing the file in the office directly. We can say from so and so road, we have run the pipeline with the diameter of this much, and the pipe quality, maybe a steel pipe, HD pipe, GI pipe, and everything is available in the GIS, because GIS and supports both spatial and non-spatial support. So this is the advantage with that. Once this network is ready, you can see the table. What is its properties? See, this is the selected one. Network one we have selected, and if you press this table, so all the data will come. Once it is feeded and it is ready, existing network, if it is already there, it will say what is the junction. Instead of numbers, you can also put the name of the junction, maybe temple, maybe school, maybe a bore well. You can put the junction ID, X coordinate, Y coordinate, and elevation, and what is the base demand. So if the demand changes, then you can select the junction 44 here, go to the 44 and change the demand and run the simulation whether the existing diameter is sufficient, how much head loss it is increasing because of the change in the demand. Because increase in the demand is all possible in the GIS pipe. If you have a reservoir, you can also, if you already reservoirs are fed, click here reservoir. So this is the junction. You can see what are the junctions, what is the reservoir and what is the pipe. If already developed one, we can click here how many reservoirs are there. If you want to add more, you can add one more here. Then you can also see the pipe, how many pipes are there, what is the start node and end node. So we can, instead of numbers, we can also edit here by name of the place. What is the road number, road name starting, and what is the road name ending? What is its length? What is its diameter? What is the roughness as per the pipe material? And what is the minor losses, and all we can find out here. And we can, if you want to change some line from going from temple 1 to school building, maybe 43 meters, instead of that is what we can say it is a demand increase, then we can modify the diameter and replace only that pipe. So there are two, this is a GIS pipe. On that you can open the AppOnNet. You can open the SWMM. SWMM we are not discussing here. We are discussing only AppOnNet. So I'm going to install AppOnNet on the GIS pipe. So this is the coordinate system. So you need to get the coordinate. That's what sir was mentioning, geotagging of all the entities. So Google Earth. So this all of us knows nowadays everybody is using. So launch the Google Earth in Chrome. Then Google Earth Pro. Take the Google Earth Pro on desktop, because we are working in the desktop. If you are working in the mobile, you can do it. somebody is working on the web connection between all the engineers and so under the SE or CE, then it can be Google Earth on the web. This is the Google Earth Pro on desktop. So this is the Google Earth Pro on desktop. We can put it. Then just it is a step-by-step procedure. So Google Earth is open now. We have taken a Ram Naresh Nagar, and this is the water distribution plant, water storage tank. We would like to design under this. So what we have, if it is only upon it, then you need to go to the field and collect the data of elevations and length, how to run the pipe. It really takes time. But here I can put wherever it is, it will give me the bottom, what is the height of it, what is elevation, what is the length from here to here, I can calculate, what is the length from place 1 to place A to place B, and all you can calculate. And based on these, based on the roads, once zoom it, it will be very clear, and we can run the pipeline. And we can also see how it can be connected internally, how it can be connected, whether the pipeline coming here to be connected here or pipeline connected here to be connected here. This all we say it is optimization and finding out various alternatives. So this is what it is. You can zoom, we can find how much length it is, what is the width of the road, whether we can run the pipeline, and what is the population here, and we can calculate present population, approximately at least how many houses and all. Then you can also calculate on time series, on the time space temporal changes, temporal resolution, you can find out how much it is increasing over a period of 10 years, 20 years, and 30 years, how much it is maybe chances for increasing this side. Sometimes if it is a reserved forest, there is no increase, but it is a increasing this side. And you can also see last 3-4 years how the which side of the urbanization rural is increasing. If it is increasing this side, so assume that this area may further come up the built up area. So we can go for a bigger diameter. So this all we can find out. So now I'm adding the easting, northing values. So this is the geocoding purpose and to open into the GIS pipe. So this is one time if you do it, it is very easy. No need to worry that this all may be a difficult task. It is very, very easy task, because as engineers we are handling huge tasks. It generally is not possible, but as engineers, we are taking that responsibility, taking the risk, and we are handling and taking the water. And if you see in the government of Telangana, taken a prestigious way, indigenous way, developing the water sectors. So it's very easy, no need to worry. So this is the ruler bar. You can find out the length and width. So you can, once you open the ruler, it will ask meters or length, millimeters or centimeters and all. So lengthwise, we can measure, width we can measure, polygon you can measure. This is all we can do it. Now I'm trying to open the Eponet. So once I know the latitude, longitudes of my area, I'm trying to open into the giving the x coordinate, y coordinate and all, lower left and right, upper left. I'm not going into detail what is a projection system, what is a coordinate system, and what is a datum, because it will take time. Once you start working in that, if you have any difficulty, you will mail us, you can call me, so that we can guide you how to install the GIS pipe, how to create the unknown coordinate networks and all. So specify the coordinates. Then if you already have some coordinates, you can convert it, you can give the layer properties. So these I'm giving all the projection, coordinate system and datum need to be given very perfectly. Then upon it started working on this. So network, it is a new network we are doing. Now if you see it is ARPANET 2 is launched on a GIS pipe. ARPANET 2 is launched on a GIS pipe. So this is what it is, an open source. And I'm trying to add the reservoir first. So this is the water HMWSSB, Hyderabad Metro Water Works, Telangana, beautifully constructed reservoir. I taken this the reservoir as an example. So from here, I need to know the elevation. Then I need to draw the networks. If you see, these are the roads very clearly given in the street map. If you load the street map, now the lines are very clearly given. Now if you see, this is the pipeline. Road is coming and ending here. No further extension. No further extension beyond this, because its obstruction is already there. So accordingly, we can calculate the diameter by seeing here. Now suppose if you see some pipeline is going here, if it is not reserved forest, and if it is a further extension, if it is possible, then go for a bigger diameter. So these are some of the observations we can do with the GIS pipe very easily, and we can take decisions and manage the system, manage the water conveyance, and we can find out by sitting in the office, what is the pressure supposed to be come here and what is the pressure coming in the field. We can compare it. So this is what various options are available. So these are select all connected pipelines, enable, disable. So suppose sometimes if you want to disable some pipelines and run the pipeline, run the network, and you can find out what is the pressure loss and what is the friction losses and all. So because suppose if the reservoir quantity of the water is may not be sufficient to run the entire network under the reservoir, then you can disable part of it, then run it, then make it 2 networks or 3 networks like that. You can divide and run it. So this is for a move option, then it is a zoom in, zoom out. These are various options available. It's a full extent. And this is the reservoir which I selected. I need to give all the properties. This is what it is a geotagging. The sir was mentioning, Bharatlal sir was mentioning about the geotagging. When you are doing the water distribution system in the GIS pipe, it is 100% geocoded. And you can put into the JJM dashboard, directly it will be connected. And you can put the head here. And all the quantity and inflow and all you can put it. And elevation, just see if it, wherever I put it, you will get the elevations and all is the elevation and latitude on this one, my area will come. The Ramesh Nagar. This is my distribution, what is the reservoir, and I can understand up to what level we can run the distribution system by gravity and if needed by pumping. This is, in fact, it is a gravity wave design here. So elevation values appear here, you can take. We need to understand there may be a little variation, little error with respect to the Google Earth, but the error is uniform in the entire area. So no need to worry with that. So this is the reservoir, then we am trying to connect. So selected the object, right? And this is all we are given the demands. Elevations at each and every place. Now it is very easy for us how to run the pipe. Because I know all the elevations by sitting in the office. So because this is the network, maybe 30 elevations, 30 minutes, 15 minutes it will take for me to create the elevations. I created all elevations now. Most difficult task in our water distribution system is elevation and length of the pipeline. So this is how I'm trying to connect from this place to this. So I need to give the demand and elevations and all. See now these are the various demands. If I selected here, demand will ask and you need to enter here. And it will give, because it is a geocoded entire area, wherever I click, I'll get the coordinates of X and Y. With respect to coordinate system, we need to understand what type of coordinate system, what is the projection system, what is the data in depth. Then enter the demand, and after some time, if you feel that it need to be changed over a period of time, that also we can calculate. And so this is how we do the demand calculation. Now demand has arrived. Such a simple. And it is a demand. Now I can draw when I need to connect from here to here, then left and right, or I need to connect from here and take continuously here, then take this side. So based on the demand, I can calculate what is the up to what demand I can run the pipeline with a less cost and less maintenance. Pumping cost supposed to be less. If it is a gravity, no issue. And you can open the Excel files on that. So this is how now I am drawing. So join to node by pipe. So reservoir to node, node to node, and various. You can also find out the length from reservoir to this node is the length. Diameter I given. Based on the type of the pipe material, I given the roughness coefficient. Then it will calculate. So this is the roughness I am entering. So this is what it is a pipe details, and flow is this direction. So we need to understand that if you want to run the pipe, run the flow from here to here in the GIS pipe, you have to digitize from here to here only. By mistake, if I digitize from here to here, system understand that we are taking the water from here to here, not from here to here. This is the generally maybe a mistake we do, but we can all verify while running. So this is the network with all the nodes and pipelines and its direction also it shows. By mistake, if I draw from here to here, it will show the which direction we are taking. And we can do the analysis that, and we can also find out the flow units. If you want to change, there are various options available. We can do it. We can take the head loss. There are 3 major equations where we can use it. Out of 3, you can select any one, but most popularly used is Hazen-Williams. So we can also use Darcy-Weisbach. It's Manning coefficient. This is the roughness coefficient for a new pipe. Suppose if it is aging is happening, so we also need to do the calibration with the old pipes. As age increases, the roughness coefficients increases and all. So this is the maximum trials I'm taking, it is a 40. So as we are having more maximum number of trials, so efficiency of the system will be more. Accuracy I gone up to 0.001. Then demand multiplier I have taken, it is a 1 only. I not consider my multiplier. You can also consider it as a multiplier demand. So it is the node view. So it has a junction, flow gauge, pressure gauge, free flex, whatever you are putting, it will put the tick mark. So if it is not there, just remove the tick mark. And this is the elevations at each and every node, which we are given. So now we can see what is elevation here, 603, and it is going this side, and we can understand how water is moving. You can run the simulation. So this is the run simulation. Once everything is ready, if you run the simulation, if it is any error, if the data is insufficient, it will come back with a pop-up window saying that this data is required. So we have to fill that data again, run it, right? If it is successful, it say run simulation successfully completed. So we can happy and see the hydraulic analysis. I taken it is a Hazen-Williams equation and all the steps and what is the duration and all it will come. Then you can view the nodes. Elevations of each nodes. I think already 12:20. I'll try to finish into 5 minutes. So you can see the nodes with all the elevations. You can also see the base demands of all that at the time of design. What is the base design? We can also find out what is the total head, elevation plus major losses and minor losses. We can also see the pressures, and if the limitation is there, if it is crossing beyond our capacity of the pipeline, then you can reduce the pressure by increasing the pipeline. So we can also see the diameters, different colors will come. Legend also come, labels also comes. It is this type of legend also comes, color legend. You can also put the labels. So then you can also see what roughness we are given. Here you are given in same roughness, so it is showing same. You can also find out what is the flow. Some place, if you feel that this is the node overloaded, then we can adjust or we increase the diameter and all. Suppose if we see this we are taken in this direction. Instead, maybe we can run from here to here. Maybe we can run from here to here. This all we can do various options. We can also see the velocities. Anywhere it is crossing the maximum velocity as prescribed. We can also see the head losses on this. We can put the label features, or we can also go for a legend. We can also see the hydraulic verification. And once it is everything, we can see the hydraulic verification. We can also check the elevation verification, and system will guide us if anything is there, problem there in the GIS file. Once this is ready, we can export. So to our reports, because GIS, we cannot copy paste it. So we can export into the Word and we can put it in the reports. So some places, if you want to separate the pipe, once network is available, you can go for a separation. So we can also check the connection tracking. So this is the connection tracking available, whether all it is connected intact. So this is what it is. We will check from reservoir to each node whether it is connected properly or not. Right? This is what it is. See from reservoir which direction the water is moving. First step. Maybe I'll go back from reservoir to here, from another loop. This is how water is moving as per our design. So this area is reaching first, and so this area reach complete, and next step it will come here. So this is how you can do it. If you don't want some part of the area need to be disabled to run the program, then you can say it is a disable and run the program, right? So flow unit conversion is there. Export from the image. So you can export image conversion of Excel files into the shape files. So open the Excel file, then we can save it to the file. This is how the data comes. Very simple. It will give node ID number. Instead of numbers, I suggest to give the name of the roads because each and every road is given with a name or ward number something. Elevations, base demand, actual demand, and flow outflow, head loss, pressure, and quality, because we are not taken quality, we are secondary 0. Each and every link also it is giving the results. Then quality where this is a profile of elevation along the nodes. So we'll get all the data. Junctions are node with the ID numbers, node elevations. This all we can export into the map, export, and we can put into the Word file for report preparation. Network input data, node elevations, pipe diameters. What is the diameter of the pipeline? Now we can see whether the red is going only for main line. See here we are separately we are running this, assuming that there may be future demand is here. Colonies are coming up. So like that. So node wise demand in LPM, pressure head on the line from the L6 to N3, pressure at the nodes, unit head loss, how much it is the unit head loss, pipe friction factor. So that's all from my side. So I think I tried to complete within 30-40 minutes. Over to Madam.
Thank you, sir. Thank you for this. I understand the time is short, and for the participants, this webinar gives the overview to understand what are the tools are available. But the exclusive session we are having from October onwards on the designs and O&Ms and everything. So we will cover massively that type of session. So don't worry. I understand within half an hour you cannot create it, but Giridhar has informed GIS5 very nicely. And one of a question was asked, because I'll close the question. Only one question is asked by one of the participants, can the GIS5 takes up the terrain mapping? Yes, because Giridhar has given the answer there. And does it consider the terrain between the nodes? Yeah.
Yes.
So that is a thing. So, and we will share the PPTs also. Mr. Giridhar's number and mail ID. Sir, kindly mute yourself. Kindly mute yourself. And we will share Giridhar sir's mail ID and phone numbers. If you need anything, you can share your thing, share your questions to us. To me also, because we'll put to the experts and get answered also. Because, this is one of an important aspect, which is open source software. And now GIS is one of an additional features which have come up. So thank you, sir, for your presence here. Next speaker, we can have Dr. Shruti. 5 years ago, when I was in water supply sectors, people always talk on water gems, water gems, water gems. It's a critical software developed by outside. So, but we have to understand whether these are the softwares which we can optimize to our category. As Bharat Lal sir was mentioning, whatever the options for our village specific, we can use it. It's not like all the software we want to use it. And Dr. Shruti, she's heading the R&D of DDK Hydronet. They also do a lot of hydraulic modeling, one of an important aspects in this. And now, Dr. Shruti, you can share your screen and you can explain briefly on this features on the water gems.
Madam, with all the permission from the participants.
Thank you, ma'am.
I have another meeting.
Yeah, sir. I will,
I'm leaving now.
Yeah, if finally.
Opportunity and patient listening. See you all sometime.
Thank you, sir. And for the last, any question and answers, if they ask, I'll note it down and I'll forward to your mail, sir, for answer.
Yeah, if I know the timing of the question and answers, I'll be again rejoin, madam.
Sure.
And 5 minutes before I'll rejoin.
Okay.
Thank you.
And now, Dr. Shruti, you can join. And sorry for the participants, because we put up to 12:40, then we extended 1:30 the revised schedule. Now we'll extend 2 o'clock. Sorry, because you know that people have been coming to address, because from the ministry it was a request. So I request to you today patiently listen it. So we'll quickly finish these sessions. Dr. Shruti, over to you.
Yes, good. Thank you, ma'am. Good afternoon, all. I hope.
Yeah, it's audible. It's audible.
Madam, you can unmute.
You can unmute yourself. Yeah.
Just a moment. I think there's some issue in sharing the screen. Once again, share it to you. Okay, so good afternoon, all. Myself, Dr. Shruti. I'm working as a head R&D in DTK Hydronet Solutions, Pune. Basically, my company is a team of hydraulics and water engineers, and we deal with water and wastewater utility engineering, consultancy services, irrigation engineering, GIS consultancy and services, then meter billing and revenue management services. And we are also a technology partner with Bentley, who has developed water gems. So as ma'am has said, that I am just here to give you the overview of water gems, because it is really very difficult to give you the complete information, but within this short time span. But I will just take you through what the water gems is and how have we applied it for master planning of the rural water supply scheme in West Bengal. So as Sir has also said in his talk in the morning, Lal Sir has said that the Jal Shakti mission, we are focusing more and more on the rural areas. So a little work which our company has done by using water gems so as to design and master plan the rural area of West Bengal, that I am going to present with you. So we all know that water is an essential element for the sustenance of the life, and demand of water is increasing day by day with increase in the population. Generally, what happens is that whenever the water supply systems are being designed, they are designed on by taking into consideration the minimization in the overall cost of the system. And at the same time, it should meet the requirements of the demand and the pressure. However, what happens is that in reality, in practice, when such system is being operated, at that time, it faces some of the issues such as leakages or contamination or insufficient pressure or pressure drops, which leads to crisis. As we can see here, a lot of incidents of water crisis. So a Niti Aayog report in 2019 has stated that about 600 million people, that means nearly half of the India's population, face extreme water scarcity or the water stress, and 3/4 of the India's rural household do not have a piped potable water, and they rely, in addition to that, they rely on the sources which are contaminated and which pose a serious risk to the health. So this particular ever-increasing demand can be fulfilled, and the problem can be solved by properly planning and managing the water resources, and with the help of sound scientific understanding of hydraulic processes that are involved and adopting the smart water infrastructure. So we all know that the smart water infrastructure is nothing but the application of smart systems in the water management, which we are nowadays applying everywhere in every aspect of the infrastructure. So this particular smart water management include monitoring and management solutions for water quality and quantity measurements, regulating leakage management, pressure management, and converting everything to real-time data application. So here in the smart water infrastructure systems, we include artificial intelligence and machine learning tools as well. So here, those particular tools, they will give us the decision on the basis of analyzing the various scenarios that we may be facing during operating those distribution networks. So it is this particular smart water systems would result into digital infrastructures and digital processes, and workflow design would help to enhance the project outcomes. So this particular smart water infrastructure results into the sustainable water supply network, which should be variable, equitable, and a viable network. So this particular smart water systems, they transform the old systems or whatever are the challenges, problems that can be recovered by planning the GIS-based hydraulic modeling system with a calibrated network and ensuring continuous water supply, then assessment of the edge of the pipeline, then it results into non-revenue water assessment and minimization of that, then demarcation of the district meter area, and such techniques which would result into or which would convert all the challenges into the various benefits, and that is possible only with the help of water gems. Because as I have said, water gems has a capability and it has integrated the AI feature into it. So as compared to the other softwares, the water gems has the speciality that it carries out the scenario analysis or what if analysis. This is basically a GIS based comprehensive tool and easy to use tool, which is developed and monitored by Bentley Systems US. So this particular software is used for a variety of applications. As you can see on my screen, it is basically used for preliminary design of the water supply system, then master planning of the area, subdivision planning, then setting pressure zones, fire flow analysis. It is also capable of selecting a suitable type of the pump, Then comes the maintenance or the rehabilitation of the pipe activities. Then for emergency planning, it also includes water quality studies, operational studies, energy management, and troubleshooting problem. So WaterGems is basically a popular tool in analyzing of the simple as well as complex water distribution network. So it works on developing, it is based on a principle of developing a hydraulic model to analyze the system behavior using certain principles. So it includes in it the Hardy-Cross method, and basically it calculates it uses the head loss as a function of a flow rate, and there are certain basic equations which are integrated into it, on the basis of which it is capable of carrying out steady state simulation as well as extended period simulation using this particular software. So it integrates in it the basic formulae such as Hazen-Williams formula, Dicey-Weisbach equation, and Chelsea-Manning formulae, on the basis of which it carries out the steady state as well as the extended period simulation. So when we start with model development using WaterGems, there are certain set of steps which are required to be followed. So it starts with hydraulic model development, then elevation allocation, allocation of junction demands, network navigation to remove any errors, then DMA demarcation, installation of pressure release valves, optimization of the number of isolation valves, and optimum scheduling of the pump operations. So as we can see here, the basic modeling starts with hydraulic modeling, and here in the model development, it starts with inputting of the data. So basically two types of data we need to give it to the model. First is the data related to the pipe, which include the pipe number, the diameter of the pipe, length of the pipe. And the other type of the data is the node data, such as the node number, elevation, and water demand. After the data is inputted to the software, it proceeds with carrying out the hydraulic run and computes the head loss in each pipe and corresponding velocity and pressure. The next step is elevation allocation. So after this, the model, this would automatically extract the terrain data from the AutoCAD as well as GIS, because WaterGems has a capability to be integrated with CAD as well as GIS. So it will take up the data either from CAD or GIS, or from digital elevation data or digital terrain models. And then it allocates after that, it allocates the junction demand or assigns the load to the junction. So it uses basically the Thiesen's polygon method so as to integrate the population with the demand, and thus the area which is covered by Thiessen polygon, when it is multiplied by the population density, it determines the total number of persons tapping the water from the junction. So this particular information is useful in dividing the area into district metered areas. So it is nothing but the process of breaking down the region into small subdivisions for the purpose of efficient water management. So here, when we divide the large area into small subdivisions, it results into leakage control, pressure management, easy tracing of the non-revenue water, and monitoring and maintaining of the water quality and improved quality and consistency. So it is very easy with the help of WaterGems. After dividing the area into district metered areas, then the PRVs are installed, pressure release valves, to avoid the bursting of the pipes and to ensure the pressure management in the pipe, which is one of the features of WaterGems. Then optimum scheduling of the pumps is carried out on the basis of the DMAs and PRVs, and optimization of the isolation valves is also carried out, which makes your network ready to be operational. Now, we have used this WaterGems software, which is the Bentley software. We are the technology partner of Bentley. So we have used this WaterGems software and applied it for the master planning of Bankura multi-village water supply project. So this particular planning was carried out by DTK Hydronet Solutions, and I'm glad to inform you that DTK Hydronet Solution is an award recipient for Year of Infrastructure Award 2 times in 2018 and 2020, and for 2020 award was for this Bankura project. So I would like to share with you this particular project. So in connection with the Jal Jeevan mission, the objective of providing safe drinking water and adequate drinking water to the individual household by 2024, DTK Hydronet Solution has contributed in developing a master plan for Bankura multi-village water supply project in 2019. So in this project was initiated by Government of India and was funded by Asian Development Bank, and it consists of analyzing and designing of the pipe network for Bankura village of West Bengal. So it was the district was divided into 8 blocks, and it was observed that this particular water in that particular district was contaminated with fluoride and arsenic. And it was observed that the arsenic levels are as high as 9 milligrams per liter. So the Public Health Department of West Bengal has selected the Bankura multi-village project, water supply project, and which was funded by PHED and ADB, and hydraulic modeling of that particular area and was carried out, as well as the design of the 4 blocks of Bankura was carried out, which was about 16 square kilometers of the pipeline network project. So DTK was assigned a work of detailed topographical survey and hydraulic modeling of distribution and transmission means. So water distribution network here consisted of designing of the pipes, valves, all the elements, pipes, valves, tanks, reservoirs, and pumps, and computation of pressure and flow in a complex network of pipes, which was a challenge, and it was done by using Bentley's water gems. So here in this case, for DTK, the region ecological upliftment were the partners. So they helped DTK in getting the aerial data, and the census data was obtained from Public Health and Environmental Engineering Department of West Bengal. So Bankura district basically has 4 blocks with 7 lakh residents living in 1,51,000 households across 655 villages. So you can imagine how massive this pipeline design network was, and it was made easy by using water gems. So those residents of those areas, 4 blocks, were experiencing water shortage. And as I have mentioned, that the water was contaminated with fluoride and arsenic. So reorganizing and master planning of pipe network was a must task. And DTK, while developing that, as I have said, DTK has used water gems. And while using the water gems, DTK has carried out the analysis of water distribution network with the help of water gems. And as I have mentioned, they followed certain steps which are inherent in the water gems, like the hydraulic model development, elevation allocation, junction allocation of the demands, then the removal of the errors, demarcation of the district metered areas, installation of PRVs, isolation of number of isolation walls, optimization of those walls, and optimum scheduling of the pump operation. So while doing so, DTK has done the customization in software, and they have added a few options as an add-on to the software Bentley's water gems, which would result into reduction of the time as well as cost of developing a complete network, water distribution network for the rural area of Bankura village. So here they use the auto relabeler, which relabels the elements in a single window, and we also developed the auto profile publisher, which automatically fetches the profile data from water gems and publishes it to the GIS maps. As you can see the screenshots or the images of that. We found that after carrying out the design of water supply scheme, which covered 1,216 square meter of the area of Bankura district and 4,000 kilometer of additional raw water rising mains, clear water rising and gravity mains and distribution network is proposed, keeping in mind the optimization of the pipe layout wherever it is possible. So by using when this analysis was carried out, we used Bentley's water gem software. So it presented numerous design options and optimizations options that were presented by the software, because as I have mentioned, it is a specialty of the water gem software that it gives us the scenarios or various cases with which what if analysis can be performed and an optimum solution can be obtained. So it is basically there exists one more tool, that is the Darwin design tool, with the help of which you can identify the best possible alternative depending upon the current situation. So all the design standards, when the design was carried out, it was checked with CPHEO manual and rural water supply schemes. They were followed and successfully achieved using water gems. And total 370 plus DMAs were formed in 64 distribution zones, and hydraulic reliability and sustainability of the network was achieved by using these water gems. And to conclude that the permanent access to safe and sustainable water supply, especially in the rural area, is basically a challenging task. And water distribution network.
Sir, I request participants to mute. One of the participants is on. Sir, kindly, sir. Yeah, Shruti, you can go.
Yes. The water distribution network has been designed for 4 blocks of district of West Bengal, and we have customized and automated hydraulic models which have been developed for the network length of 4,000 kilometers and evaluated using Bentley's water gems. The network is analyzed and optimized for various possible scenarios so as to ensure the reliability and the sustainability during operations. And DTK developed a custom program such as Auto Relabeler and Auto Profile Publisher. And 370 plus DMAs were formed in 64 distribution zones. So it has resulted into a quicker master plan for the rural water supply. And this is one of the contribution of DTK HydroNet solution as to use the powerful tool of water gems for designing of the rural water supply schemes in connection with the Jal Shakti mission. So these are some of my references. Thank you. So as Madam has said, I have just given you the overview of the software and the application which my company has carried out regarding development of master planning for rural areas. So no doubt in detail sessions would be required so as to understand the software in detail. But in a nutshell, I would like to tell you that this particular software has a specialty as to carry out the scenario analysis and what if analysis, which is the special feature in this particular software, which uses the Darwinian principle under the Darwin tool and present us numerous alternatives which the engineers and the planners can choose so as to optimize the design and implementation as well as maintenance of the water distribution network. Thank you.
Thank you, ma'am. We will take the questions late because, we have other speakers already. It was late. So now I introduce Dr. Pradeep Kalba, Associate Professor, Center for Urban Science and Engineering, IIT Bombay. Welcome, sir, for this session. And sir is explaining on Jal Chandra, which is an indigenous software developed by IIT Bombay on the optimization of the pipe water networks. And exclusively, they are testing for the rural water supply schemes. And now I request Dr. Pradeep Kalba, notwithstanding more time, to explain on this. Thank you, sir. Thank you.
Thank you. Can you allow me to share the screen?
1 second.
Yeah, sir. Now you can do it, sir.
Yeah. Okay. Okay. So I'm sharing the screen.
Participants, you can type your questions in a Q&A box and chat. We are cumulatively collecting it and answering it.
Can you see the screen now?
Yes,
Yes,
sir.
sir.
Yes, it's visible, sir.
Okay. So welcome all, and thanks IISS for giving us opportunity to present the Jalatantra tool, which is an in-house development at IIT Bombay, which is a free tool for optimal pipe water network design. And currently this tool optimized branch type of network and loop type of networks is under development. And I'll tell you why we are not yet released the loop network optimizer. So basically this is a huge development happened in last 5-6 years when Professor Om Damani from Computer Science and Engineering Department at IIT Bombay with his student has started this development, and now we have collaborated with to further improve and disseminate this tool. And I have been working in water supply sector and interacting with many PhDs across India to demonstrate the low-cost solutions for water supply. And one of these is Jaltantra. And today I'm going to introduce you. So typically the water supply systems that we design can be single village or multi-village, where we have the source, water treatment plants, MBR. And then so basically we have to design the transmission network, which is the black lines, and then the distribution networks following the ESR or a GSR. That is the typical requirement of hydraulic design, optimal design. And don't get confused between a hydraulic design and a simulation. And I think you must have been going through a lot of knowledge sharing in this webinar and other sources. First, you have to optimally design the system. That means for a given demand and for a given peak factor, you have to determine the pipe sizes. And then you have to simulate the system in EPANET or other tools for checking the performance for the current year and performance after 10-15 years and performance of the ultimate stage. But the most important part is getting the optimal size of the network. Jaltantra is an optimal designer tool. It's not the simulation tool. You can take the Jaltantra output to EPANET or any other tool to simulate the behavior. But for small scale rural water supply systems, that is not much needed. You can take the output, and many of the in Maharashtra and other state, people are using Jaltantra directly for their official DPRs. And I will show you some examples how to do that. So we have developed a very user-friendly Excel-based system, so that if you are using the branch, many of our colleagues are from trained to use the branch, which the World Bank developed by IIT Bombay in 1982-84. That time, World Bank software. The World Bank is Jaltantra is just an advanced improvement in branch algorithm. So Jaltantra use integer linear programming approach and gives you the most optimal cost for branch type of networks. So basically we have to determine the demand for Jal Jeevan Mission. It is 55 LPCD, or you can use 70, whatever guidelines you are using. That demand you have to use, and using basically simple line-based demand allocation, you can determine the demand at each node. And you can determine the demand in liter per second. And for that given demand for each node, for example, this node, or this node, you can create a node numbering on a simple spreadsheet or on a plain paper. I will show you one example. And then you can input that in a Jaltantra, and Jaltantra will give you the optimal result. Typically, our systems use this demand pattern, which is not exerted on ground. Ground reality is very different. But our design guidelines as per CPHUO stipulate that we have to use this peak factor of 3 for rural water supply. So don't debate right now why 3 and why we can't change now in this session. Just understand we are going with the 3 peak factor. This is for rural areas. Typically, you will be in Jal Jeevan Mission using 3 peak factor. And I will explain how to do that. And then based on the design guidelines, water supply systems in India are designed either using free or commercial software. Free softwares are Branch and Loop, which were DOS-based system. Right now, it is very difficult to use them. Still, in some of the PhDs, I see that people are still enthusiastic to use this software. That is good. If you are using, no problem. But now we are giving you an option to use Jalatantra, which is a Windows-based software. You can use it on mobile, you can use it on your laptop, desktop, anywhere. And for simulation, EPANET session and commercial software already introduced to you. You can use it. If required, you can use the simulation, but for small schemes, you may not have to do that. So need for the Jaltantra was, we wanted to develop a free design software the DOS-based system Branch has a limited number, 100 nodes you can solve. Now Jaltantra can solve any number of nodes. Commercial softwares are costly, complex in nature, not suitable for rural environment where that much complications are not needed. For cities or metro cities, you may need a more GIS-based system. So to provide free and user-friendly software with capability to optimize the large network, was the aim with IIT Bombay worked with. And Jaltantra is a free software. Anybody for education, research, or commercial, or for Jal Jeevan Mission, any of the program, you can use it. It uses integer linear programming. All the work has been internationally verified, published. So it gives you the most optimal solution. It has Google Map integration. You can use Google Maps for drawing the map and feed the data to Jaltantra. And it's a best optimal solution for branch network and no restrictions on network size. We have not released yet loop version because optimizing loop network is a very, very challenging task. Commercial tools claim that they have the optimal solution, but that is not mathematically possible. Even if anybody is claiming, that is not correct. So unless we are sure, with some notations, we will release the loop version of the Jaltantra. We are working on in-house with students with limited resources. We are not charging it to anyone, so it is in-house effort, so it takes time. We'll write a Jal Jeevan Mission director to support us in this initiative to provide us some fund for doing the development. So let us, and also the loop is not implemented in ground. Even if somebody is designing, I have not seen a system across India. I have studied water supply systems, and correct me, the practitioners, operationalizing loop in Indian system, intermittent water supply, is not possible. So just forget about loop system right now. Let us design the branch system. So we have compared with the branch, and you can compare it with any other commercial software. You can see that for any number of nodes, what is the cost that is given by the branch software and what is the cost given by the Jaltantra, and the computational time is also given here. So you can so this kind of open comparison you can do with the Jaltantra, and if you find any difficulty to understand or any more better algorithm, please communicate with us. We are happy to correct ourselves. But it has been tested widely now in Maharashtra Jeevan Pradhikaran, and many of the PhDs are using this tool in official Jal Jeevan Mission DPRs. And Jaltantra has integrated with Google Maps. You can just start drawing with using Google Maps, and using the Google Maps, you can directly draw your network and directly input into the system. So step by step, you have to give the node general parameters, you have to define node details, you have to give pipe details, commercial pipe entry you have to make, and then Jaltantra will give you there are advanced features also, pump optimization, ESR optimization, but that's not needed right now for the rural schemes. So basically Jaltantra can give you the optimal pipe diameters that are there. And documentation is available on this link. I have already shared the presentation with IHS and the reference material. This kind of very user-friendly interface is there. I will show you in a minute. And the Jaltantra use and acceptability is increasing widely in Jal Jeevan Mission. It has been officially adopted as one of the softwares in Maharashtra, and it has received IIT Bombay's Impactful Research Award. And Jal Shakti has released the advisory to use Jaltantra and many other low-cost solutions from IIT Bombay, and have given the reference here. And more than 10 Jilla Parishad in Maharashtra and many PhDs in other states are using Jaltantra. In July 2021, we have 4,000 user events. You can imagine the amount of users that is happening across India of Jaltantra. And this is some of the selected from that 4,000 users, Maharashtra Jeevan Pradhikaran, and we don't know also their names. Because it is free, we just log in the database that who's using the scheme. And you can see already people are using it for Jal Jeevan Mission. And these references are available here. And we can conduct detailed hands-on training sessions on Jaltantra of 1 day, 2 day, and we are looking for a really collaboration and support for further upgradation. So in a couple of minutes, that time I have, I will just show the actual network. It's a very simple network that you can draw on your on a paper. You just number it. The node numbers you can give as 1, 2, 3, 4, 5, 6 based on your survey. You can pipe number 1, 2. You can length from survey. You can find out the lengths are given in red color. The demands in liter per seconds are here. So that if once that data is ready with you, you can use Google Maps feature of Jaltantra or your own survey team. You can have this network on your paper, and then we can enter this data. And I'll show you how to enter the data. Can you see the screen, Jaltantra screen now? Present.
We can see.
Yes, sir.
Yeah.
We can see.
So you just type Jaltantra IIT Bombay, CSE IIT Bombay. This will emerge, and you have to just click this Jaltantra CSE IIT Bombay. You have to just sign up because now we are logging. Earlier 2 years we are not logging for the users also. Now at least we have started so that we can know which are the users. So you just very simple user form is there. You sign up. Once you sign up, you can log in, and Jaltantra gives you this kind of interface where you have to give this general tab information, a project name, the default pipe roughness can be 100 or 140, whatever you want to keep. Minimum node pressure, head loss can be 5 or 10 meter per kilometer. Whatever information you are used to give in branch, you can give it in Jaltantra. Source elevation and head has to be given. Always the source node will be number 1. And as per this diagram that I have shown you in the presentation, this data is entered manually here. All the node numbers from 2, 3, 4, 5, 6, 7, 8, 9. The demand in LPS on the demand nodes, the elevation. So it's just you're filling the Excel sheet, that's all. Then you have the pipe details. Again, using this pipe details, the length and pipe for pipe number 1 to 2, or node number 1 to 2, what is the pipe number? All that details are fed here. And diameter is not given because software will tell you what is the diameter to be allocated for the given network. And then there are commercial pipelines available in the market. Using your district schedule rate, you can input this particular cost table. And then you just have to press this optimize button and it will show you done. And the results you can verify here. The node pressure, residual pressure is more than 7 meters. Pipeline details are given here. The same report is generated as branch. For each pipe, the cost is given, and in the cost, cumulative cost is also given for the entire project. And you can have the input saved so that you can in Excel file. With the short amount of time, I'm not able to show you how to save and import the Excel file, but very well formatted report can be generated as input and as the output, which shows you all the pipe results, node results. This can be directly printed and put in the DPR, and people are already doing that. So we'll be happy to provide you more hands-on training if you contact us at IIT Bombay. Through online or offline mode, we can do it. So that's all I wanted to tell you in a very brief amount of time, so that at least you are aware of the Jaltantra system. You just have to type Jaltantra IIT Bombay and this interface. That there are YouTube videos uploaded, which is already there. And there is a Google group also there, Jaltantra Google group. You can join, and any query our PhD students or MTech students will reply you. Again, this is in-house, completely on our own we are doing. So whatever possible, we will reply. And yeah, happy to collaborate further. Thank you.
Thank you, sir. Participants, any questions you can write in the chat box, sir. It's very nice. Actually, I think people need hands-on experience in this. So they will be in contact. I'll give your name and everything. You can also support us for this cause. Whenever people is there, we can collaborate. Being an academic institute and research, we'd also collaborate for this because it's a new software. We also should understand as you said, the branch mode. Not for the detailing, so these guys can work for the small villages schemes and everything. So that's a priority which we are giving here because mostly people knows other softwares, but this is a new for us totally. So I feel it and happy that you have shared it that, sir. I think more queries will be there. I'll be in touch with you. Thank you, sir. Thank you.
Thank you.
And participants, any question you can put in a Dropbox and Q&A box chat. And next we have the last presentation. Dr. Abha P. Sharonkar, Principal Scientist, Cleaner Technology and Modeling Division, National Environmental Engineering Research Institute, Nagpur. She is talking on the pipeline condition monitoring softwares because, it's very important aspect. You are going to lay a lot of pipelines, already laid actually. So you have to understand the best condition monitoring on this. And this is also a risk pipe software modeling which was developed by NEERI, everything in the testing stage. And as Pradeep also mentioned that it was already validated by Jal Jeevan Mission. So you don't have any harm in using it, because some people asked it. And so pilot scale, when you give your village as an example, only people can test it also. So that's a forum which we want to develop for you. Now I request Dr. Abha to share the screen, and then can explain on this.
Yes, good afternoon all. Good afternoon, everybody. Am I audible?
Yes,
Yeah, yeah.
Okay. Thanks to IIHS for this, giving this opportunity to present our software RISC-PyNet to the participants of this webinar. Thanks to Shri Aruma Ravi, Director IIHS, and Shri Bharatlal ji for guiding us on the use of technology in water supply system management. I will share my screen in a moment.
Yeah.
yes.
Can you see?
Yes, madam.
Yes.
Okay.
Yeah, ma'am. We can see it.
Yeah.
You can put it in presentation mode.
Yes, yes.
Yes. Just a
Yeah.
Yeah.
Yes.
Yeah, thank you. This is our indigenous software for pipe condition assessment, or you can say condition monitoring of pipes through software modeling. We named it as a RISC-PyNet because it also in addition to pipe condition assessment, it also supports contamination risk assessment for water distribution system. So it's a solution for pipe replacement planning. And we all know why we do replacement of pipes, because we want to reduce the non-revenue water which is lost through leakages or pipe breaks and bursts. And we also want to improve the drinking water safety, or we want to ensure drinking water safety, because many complaints about contaminated water supply are reported through distribution network. So thank you IIHS for this giving this opportunity to showcase our software. My presentation outline is just in a brief. I'll introduce, because most of us know what are the challenges in water supply system, what is the objective of Jal Jeevan Mission, and what is the need for software technology. In addition to RISC-PyNet, we are also working on another technology, SAFRA WDS. I will briefly touch upon it to describe what is the purpose of SAFRA WDS, and in detail I will show you the RISC-PyNet software. What is today? It's not that today we are not maintaining our water supply systems, but what is approach, that is the reactive approach that we are following, and what is the preventive maintenance approach that we aim at by implementing RISC-PyNet. What is the data requirement and features and validation of the software that we have carried out. And if any urban ULB is going for PPP contract, then what will be the role of RISC-PyNet in successful implementation of public-private partnership? What are the benefits? So we all know National Jal Jeevan Mission is envisioned to provide safe and adequate drinking water through individual household tap connections by 2024 in rural India. So if we see the objective of Jal Jeevan Mission, then today, what we see, we have a water supply infrastructure in urban areas, which is where the cities or the ULBs are responsible for 24/7 safe drinking water supply to the consumers in cities. And many cities have hundreds or thousands of kilometer long infrastructure or pipe distribution network, but they are unable to supply 24/7. And the main challenge with what we say is the non-revenue water. Many cities are reporting more than 30–40% non-revenue water, and thereby they are not unable to cope up with the revenue generation and provide safe drinking water supply 24/7. So all of us know that urban water supply systems are mostly, in most of the cities, have intermittent water supply. In many areas, we have low pressure water supply. There are customer complaints. Also, there is no willingness to pay and no metering, and thereby no revenue generation. So the issues what we find that the pipe breaks and bursts and the water which is lost because of leakages at joints and walls, all these cause of water loss and contamination issues at the dead ends and because of open drains and broken sewers in the city. All these issues is a very complex system, and it becomes very difficult for the utilities to provide 24/7 safe drinking water supply. So with this scenario, the concern what we also have, all of us also have in our mind, today this is a scenario of urban area or cities. What will be tomorrow? We are giving today we are talking of giving 24/7 safe and sustainable water supply to rural areas. But will this be a scenario in rural India after 20 years? It will certainly be if we don't take care of our systems, which we are laying today for rural India. So it's very essential that we take care of this, our infrastructure, what we are planning to install for rural areas, rural villages and rural population in villages. And we take care of the system and we maintain that system to make it sustainable. As Bharatlal said, we want it to be working for long term, long and not for a short term. It's a not short term goal, it's a long term goal. So it's very important that we take care of the system starting from the beginning, that since it's late, since it is installed, since it is in place, it is being taken care. And then how do we take care? It should not become like this, that 40 supply % gets wasted. Many cities are running out of water. There are water cuts for several days in many cities, or there is contamination issues in water supply. So if we don't want to happen like this with our rural water supply schemes, then it's very important that we take the advantage of the software technologies so that our water supply network becomes sustainable. So if we look at the number of households that have tap water supply, it's more than 19 crore, which was earlier only 3 crore. So the number of households that this, of course, this is not today's figure. This is few days back number. So if we look at such numbers, if you go to the dashboard devised by Jal Jeevan Mission, we will find that every day this number gets updated, and there are several districts who have 100% functional household tap connections. So several blocks have attended these things, and many panchayats and many more than lakhs of villages have attended 100% functional tap household connections. So huge network data is generated out of this activity. So if we consider even one rural water supply scheme, then lakhs of villages will be a huge database. And this database will be a geospatial data associated with some numeric data also. So this geospatial data obviously has some engineering drawing, which is in CAD format or nowadays GIS format. For each village, there will be some drawing with location of walls, functional household tap connections, location of source or storage, then pipe material used, pipe length, diameter, at which depth it is buried, the installation year. And so all this data where we are going to store. Today it may be on paper or with somebody in digital format, but how can we have a centralized storage? So we at NERI are also developing a systematic database framework to store water distribution system data so that it can be used in long-term for operation and maintenance of rural water supply schemes. So this is in brief about SAPRA WDS. Today, what I am going to demonstrate is a risk PINET, which is a pipe condition assessment and replacement planning tool for the water distribution system. So the purpose, this will be a sort of scheme that we are planning to develop, that once you store a digital data of your supply network of different villages or different Gram Panchayats or ULBs, then for several years we will be able to maintain it and use it for decision making. So as you know, these water supply schemes are going to generate huge data. It's very essential to have a systematic database framework so that you can use decision making tools like RISC-PyNet, which support pipe condition assessment, contamination risk assessment, and if you want to have a replacement plan of your old network, then you can prioritize the high risk pipe for replacement and have its cost of can estimate the replacement cost also. So the pipe condition assessment model is has three in modules, inbuilt modules for hydraulic it simulates the hydraulic performance of the system. It computes the pipe break rate and the remaining useful life of each pipe in the network, and gives you how the pipe is, whether it's good, medium, or in bad condition. Then it evaluates the contamination risk, because as you know, there can be sewer pipelines which are crossing with the water pipe, or there can be open drains or broken sewers which contaminate the soil, and thereby the contaminant intrudes into the water pipe because of intermittent systems. There is negative pressure in the pipe, and the contamination, when intrudes into the system, the people can complain about the contaminated water supply. So it also has a facility to have exact contaminant intrusion point location tool, and it gives you the classification of pipe as high, medium, and low risk of contaminant intrusion. Then based on that, you can prioritize your pipes for replacement and estimate the cost of replacement depending upon the choice of material you want, diameter and length of the pipe that is to be considered. And based on your investment plan, you can have short-term and long-term reinvestment plan or replacement plan of the network. Sorry. So it's not that today we are not doing replacement, or today we are not attaining the customer complaint, but the action what we are taking is a reactive approach. Whenever there is a complaint, we repair the pipe, or we replace the pipe, we renew the pipe. So in the process, there is a lot of non-revenue water which is lost, and many times by the time we replace a particular portion of the distribution network, the contaminated water is already consumed by the people. So can we have a priori knowledge about the bad condition pipes in the network? Can we have a priori knowledge about the contaminant intrusion location? That was the concern we had. And since we had been working on water safety plan projects in many cities in India, we had developed these tools indigenously so that we can use it in India, because these type of issues are mainly reported in developing countries where the contaminated water supply reaches the consumer. So if we look at the typical scenario, if we are investing so much on treatment and distribution, but if we look at the real losses or technical losses, there's a huge loss of water as well as revenue for the ULBs, and that's why they are not able to supply the 24/7. So this should not happen to the villages. This should not happen to the Gram Panchayats or the water supply schemes which are coming up in rural India with the Jal Jeevan Mission. So if after some years, if your network gets corroded, then one should not think of, should I replace all CI pipes, how to derive a strategic replacement plan, and how he can have the decision making he can use a decision making tool with the data which is available to us with him. For every village is the owner of his water supply scheme, and of course then he is the owner of his data also. So here we come in picture that we can support you in decision making with strategic management of your network if you keep your data systematically right from the beginning. So we have a SAFRA WDS to keep your data, and you can use RISC-PyNet decision making tool, where today your whatever CAD file or shape file you are generating for your network, you just keep your database in standard format. Each pipe length, material class, diameter, installation year, buried depth, pressure today with which you are operating the system, soil in the network, soil type in your area, and road if it's there. Then you can have, after using this data, you can have a pipe condition assessment, pit depth or wall loss after certain years, what will be the head loss, how it is, your system is performing after say 15 years or 20 years, number of house service connections which are damaging the network at several places, then external load or backfill load and traffic load which is also harming the condition of your pipe. So you can have the condition assessment of your network maybe after 5 years, after 10 years, or after 15 years, how it will behave, which pipe will go in bad condition and it will need replacement. Also, if you have a sewer network in place or open drains in the cities or in the villages, then what will be the crossing of a drain with your water supply pipes, and where the contamination can occur in the water supply network. So you can also validate these results using field survey or customer complaints. Of course, if the network is not there at present, then there's no question of customer complaints. But if in present condition, in present urban areas and with ULBs, if there are customer complaints, they can validate their results of RESPINET for pipe condition assessment as well as contamination risk assessment. These are the software screens. It's a simple and user-friendly software with built-in GIS features. It supports OpenStreetMap so that you can exactly locate where you are going on the ground, and validation of input data. Then you can have a cluster of customer complaints to validate your data, and you can identify critical pipes which need replacement. So you can have optimum replacement plan of the network and to address your non-revenue water reduction and the complaints of leakages and contaminated water supply. So it's a very user-friendly, you can see pipe condition assessment, hazard and risk assessment. Also, you can estimate the cost and generate the report automatically for the decision makers. So this is one of the study that we am showing you in Nagpur. We have done with the pipe condition assessment and contamination risk assessment. It labels the pipes in red color, which are in high risk of contaminant intrusion and which are bad in condition. Then yellow color for medium condition pipes, and blue color for light cyan color or blue color for good pipes in good condition. The dots indicate the complaints of leakage and contaminated water supply, and this way you can identify which are the critical pipes which you need replace. If you replace, you can address maximum number of complaints by replacing optimum number of pipes. Of course, you can go on the ground and validate your model results, which we have done in this study area with more than 80% accuracy. So why do we need RESPINET? We all know that many cities, they go for water audit to assess the non-revenue water and to assess the performance of their network. But if you want a service improvement in the service delivery as it is talked nowadays, and ensure safe drinking water supply, continuous sustainable water supply, then instead of going for conventional pipe condition assessment techniques, which are invasive techniques and that hamper the traffic, inconvenience to people, you can go for RESPINET, which is a desktop-based assessment with the systematic data analysis tools. You also have a choice of non-invasive techniques, which are acoustic signal-based techniques, but they will not give you the condition assessment from node to node or for each pipe in the network. So they will give you average minimum wall loss in certain sections of the pipe, which are also very costly and not very comfortable for everybody. So here we introduce the RESPINET. What are the benefits? It gives you a priori knowledge about the system or about the failure probability of each pipe in the network. It tells you what is the remaining useful life and contaminant intrusion point into the water supply network. Based on your financial and timeline constraints, you can have short-term and long-term, that is strategic and tactical plan of replacement. you can plan for your investment, you can reduce your inline assessment and have improved water supply network with improved water quality. So if today what we see that many cities are going for public-private partnership, and there is a contract of replacement of certain amount of network, and of course with rehabilitation or replacement issues, there is metering and tariff issues, and the contractor has to address all these challenges which are there in the cities for with large network number of DMAs and this. But many times what we find that replacement action is taken only on the basis of hydraulic modeling, which is demand driven modeling. So there is no use of any other technology. So if you want to bring in the reforms, you can have the use of this type of technical expertise, intervention and use of these technologies. You can allocate certain amount of budget so that you can identify the critical pipes using these software techniques, and you can have adequate project preparation plan. Otherwise, what will happen, many private PPP models, they have not been successful because there was a certain plan of replacement, but there was no adequate or exact plan of replacement with investment that is required. So there was a lot of financial risk involved on part of the contractor as well as on the part of ULBs. So there was no mechanism to resolve this issue, and many times then the contractor he compromises for the choice of pipe material which comes into place in the cities. So if to avoid all these complications, you can take the advantage of these technologies. And SPINET is an indigenous technology which we have developed at CSIR NEERI, looking at the constraints of Indian situation of water supply networks and database available in Indian cities and the problems of water supply network. These are our previous studies, then various DMAs that we have conducted in Nagpur. Since 2008, we have been working for Hyderabad in number of DMAs, Adikmet, Moinba, Serilingampalli. In Nagpur, we have done SPINET assessment studies in various DMAs and also in Amravati in Maharashtra state. So this is our project team. I thank you all for listening, for giving this opportunity and listening to my presentation. If you have any you can log into our SPINET WordPress.com website. For more details, you will get our details over there regarding the software. And we are ready to work in collaboration with any of the municipal corporations by giving either services or license of the software with training and hand-holding. Or we are ready to support this, give the services for SAFRA WDS also, where the municipal corporations or Gram Panchayats at village level can upload their data, access their data, update their data of operation and maintenance, and use it for decision making. So we are ready to do hand-holding for our services with any of you for municipal ULBs as well as for rural water supply schemes. Thank you all. Thank you.
Thank you, madam. Thank you, madam. It's a good overview session on how to use it. Anyway, we have a design, O&M and retrofitting sessions coming in November. So participants, I request that we have sent a full calendar of JJM to you. A lot of chief engineers, ENCs is there in this. So we have sent it, and we will also once again share it to our your mail ID also. So you can attend the detailed session. Regarding software, we will talk to the concerned person whether we can because we have to get permission from JJM also to promote that, so we can use it that. Until the importance of these training program, it's not simply a training program, it's an experience sharing, and we should also understand from you what is exactly happening at your level, because today 120 participants with 11 states have been attending. And so it's a huge database for us itself to understand better what you people are doing it. So my point is that We will share our mail ID. My mail ID is shubha.muthukumar@ihs.ac.in and my colleague's mail ID. Any type of Jal Jeevan related water supply things. If you're making an interventions, or if you're making any source sustainability measures or any case study is there, kindly post it there, because we want to understand what other states are also doing it. This is only a sample which we call 4 faculties, but other things also we should understand better. And because Jal Jeevan Mission is so particular that we need an end user, not a feedback, end user compliance system, whether they are going to use it or not. If you try to use it, Jal Chandra or Respite or Water Gems, what you feel as a merits, what you want to understand challenges. So if that is there, the inputs to us, then it will be easy for us to navigate through all the experts and get your solution or challenges, whatever maybe it's respective. I thank once again all of them. And I will request some like 2-3 questions I can see in the chat box, which is answered already. I need participants to raise a hand. We'll have some 5 minutes question and answer. Anybody want to have any questions? Can you raise a hand so that we will take it one by one? I think already it's a lunchtime and you people have been patiently listening all these things. Yeah, somebody asked me it is possible to give full training on EPANET and Water Gems. It's good. Through Jal Jeevan, I will get permission and I'll let you know, because now your mail IDs is with me, so I can pass it on to the calendar. Ultimately, the Key Resource Center is working like a partnership between the states and the technical intervention people. You have to get benefits. Definitely, we'll look into this matter. I'm taking all the points so that I'll take to the secretary. These are the things which participants asked it, so you have to approve it so we can conduct as a training institute. Anybody raise the hand? Binu A. Nair. Sir, what the question you have?
Sir, you can unmute and
you can unmute and ask the question. You have raised the hand. Sometimes mistakenly also we raise the hand. It's a lunchtime, so better leave it. So I was so happy to see all the rural water supply people here. It's one go with 120 participants. It's nice that Binu is there, or you have raised it. Otherwise, you can write to me. My mail ID is shared, shubha.muthukumar@ihs.ac.in. I am the nodal officer for KRC from IHS. Any inputs, anything we are going to give to you, so you can write to my mail, you can copy that. And then secondly, we have provided you a feedback form in the Google link. It's mandatory to fill it. The output, like EPANET and distribution, the output will be your certificate. So better fill it because it goes to ministry, who are the people attended. You can give your comment also, because we take it that to upgrade ourselves in the next. And any question regarding GAS pipe, there is one question. And in Water Gems, there is one question. Can you roll down? One of our participants asked on the Water Gems, because the issue, in Water Gems, to design the water distribution network, if more than one source in a single network, then what is the design procedure? It's a huge design procedure, actually. It cannot be explained in one question what you asked it. The answer is yes. So if you want to conduct detailing, we will do that. That's an answer. And second one, there is another questions like there is another question, how to calculate the head if water is pumped directly from borewell by submersible motor pump set to the distribution system. Giridhar sir, can you answer it? Or anybody in panel?
Yeah.
Giridhar sir is there? Yeah, Pradeep, Dr. Pradeep.
Yeah, so basically you are saying that you want to directly, I assume that you directly want to pump the distribution.
Yeah.
Yeah. So basically you assume 7 meters at the node, the farthest node, and take that difference between that. Ideally, you should have a storage tank or a shaft between the distribution system and the pump. You always have some isolation from the pump and the distribution. So in Rajasthan now people are building shaft. In Safale Palghar also we have built a shaft. But the head will depend on, so usually what you should assume is determine the ESR level that is required and then design pump for that ESR level. Whether you pass it through the ESR, whether you pass directly through pump is a different question. Okay, so level will remain the same because 7 meter you have to achieve on each node. So design the system in Jaltantra or whatever software you want to use and determine the ESR level and design the pump for tube well to that ESR lowest FSL, okay, full supply level.
Yeah. Thank you, sir. Any questions? Because these are the questions, because 5-6 questions we have answered already in the chat box. Any questions? Okay, if it's no more question, kindly fill the forms because it's very important. And second thing I want to inform you, next week, Tuesday, we are having 21st Source Sustainability webinar. It's 10:30 to 1:30, actually 12:30, but it's extendable. And so sustainability. And then we have 28th webinar on geotagging of asserts. So what are the tools we can use it? So you people can register for that because webinar doesn't have any sealing of the participants. So that's a mandatory from the JJM ministry. So you can attend that. So you can go through the nomination through your chief engineers and the ENC's approval. So that I want to mention, and we can also personally send you mail for the registrations also. So there you can register and kindly fill the form. And I thank all the, first of all, I thank JJM, Mr. Bharatlal, who have been given a very good space for us to work in this rural water supply. As IHS, we are going to do level 1 and level 2. Irrespective, we are also calling the community level people to talk in our program because ultimately this is going to transfer to the O&M or whatever we call to the community level. So we are bringing them also to the set of audience. And up to March, we are doing 29 programs. So highly attend that. And second, I thank Mr. Vishwakannan, Director Training, who have provided us, who have also organized the way we want to do the program and the audience and everything. Third, I thank all the states who have represented their nominations in a short durations. Totally, it's 120 nomination. 11 states have come. Andhra Pradesh, Telangana, Karnataka, Bihar, and we have Meghalaya, Haryana, Punjab, West Bengal, Mizoram, Manipur, and these are the states which have come. We are expecting other states nominations also. So thank one and all for this. And finally, I thank my team, IHS team. I thank our director, Aromar Ravi, and my head, Geeta Krishnan, and my team members, Mr. Srinivas, Harish, and Anil. And the final two thanks, big thanks to the panelists, Dr. Pradeep, Dr. Giridhar, Dr. Shabana, and Dr. Shruti, because without them, this cannot be successful. And definitely we'll take with Pradeep the Jaltantra, which people are asking more of the programs, and also with Abba. And definitely Giridhar has introduced a very good system on the GIS pipe. It's a very recently one, so that is also can be used it. But one thing I can tell you in this 5-6 years journey of using the software, until you use it, you doesn't understand. It's not like a theory. 3 days we conduct the program, and 5 days after 1 day we'll forget that. But if you think that you have to use it for your network, definitely use it. Then only you can find out the merits, demerits, how to overcome it. That's an experience which we had it when we are doing the training or when we are doing the projects. So I thank once again everybody, and kindly film. And also sorry, Assam is also there. Sorry for that. In the 11th state I missed it, Assam, and more representation from the Northeast this time. So we want to work with you more, and any queries, any type of activity which you're performing in your rural thing on source sustainability, planning, community involvement, you write a mail. So your case study will be presented. You can present in our next sessions because, ultimately we should understand what people are doing it. with no more, it's not bad, 15 minutes extra. It's not bad that we have done it more. I think, thank you to one and all once again. And we can close the session with no more thing. And the link will be sent again to all the people. And my colleagues are murmuring here. 1 or 2 people, can you unmute and tell how about the training? 1 or 2 people represent from the states, Bengal, whatever the volunteers. Can you tell me the feedback? Yeah, Nagaraju sir.
Yeah, I am superintending engineer from Bangalore circle.
Yeah.
So the training was very nice, and we are very curious about it. And my question is that this software, how can we get it? Whether we will be provided through our department, or else if these softwares are freely, we can use it. That's my question. And for further course of training, the participant who have today participated, they only can be selected because they will have a little touch about it, and they can gain some more knowledge about it, and so that they can practically use in their works, and we can use optimally these what is innovative softwares. Thank you.
Yeah, sir. Thank you, sir. We'll put this point. I am point taken already. I'll put it this. So Puducherry also is there. Sorry, Yuvraj Ram has mentioned that. Puducherry also is there. Thank you, sir. Anybody, sir? Karnataka is represented. Any Northeast state? Any UTs? Volunteer? And this session is live stream in JJM YouTube channel also.
Yes.
In later case, you can record it, and we will send all the recordings to you. So don't bother. So we will send it everything to you. Anybody, sir? Because I don't want to name it. It's 120 name. I can see only 10 people in my screen now. Ajit Kumar, Sundaresan, Shivananda. Anybody can tell it. We can close it as it is. Okay, I think people are not in mood. I think you can fill the forms, and then thank you once again to all the people being here. So we will do more programs, and hope you attend most of our programs. And up to December, I kept online programs. From January, we are starting offline, because offline is always an offline. So it be interactive, but I could not help due to this pandemic. But up to December, I'm seeing the situation, how it comes. From January, we are having complete offline. So come, and mostly we are conducting in our Bangalore campus. So thank you one and all. This is Dr. Shubha Muthukumar signing from this webinar. Thank you then. Thank you. Thank you.
Thank you.
Thank you.
ma'am.
It's not opening here.